We are on day 2 of the Code Bootcamp Cohort 12. Yesterday, a lot of the things that we covered was really an early introduction to working inside of a terminal, working inside of Bash. We learned touch. We learned how to change directories. We learned how to make files, how to edit files in the command line. And what we're going to jump into today is really going to reinforce that behavior because we're going to be learning version control for the first time. So just as a super quick refresher, let's dive into what we learned yesterday. Hi, Wendy. Okay, let me make this a little bit bigger. So yesterday we learned, and it was reinforced in the homework. We made a directory. We made some files. We learned to change into the directory with the cd command. So cd test2 will move me into the test2 directory. Cd ... will move back up a previous level. We can look at what's in a file by using the tail command or the head command. Does anyone remember what the difference between tail and head is?
I have a question. Did you want us to see your screen?
Yes, I am definitely recording a screen for you to watch later instead of sharing it. So,
okay.
Yeah, thank you. I appreciate it. Yep. So we're just doing a real brief refresher. We cd'd into a directory. We learned how to tail a file and how to head a file. What is the difference between those two?
Tail shows you the last 10 lines and head shows you the first 10 lines.
Perfect. Does anyone remember how to get the number of lines that we check in tail or in head to be different? Yes, Andrew.
Tail dash in.
Let's say 20. Oh, let's say 4, 5. 5. Yep. Excellent.
Can everybody hear me?
Yeah, that was perfect. That was exactly the right answer.
Sorry.
Yep.
Okay.
What is the text editor that we learned to use yesterday from the command line?
It was Git. Oh no! What did you ask? What was
the text editor that lets you edit files and write in it kind of like Notepad?
Oh, Git. Yeah, no, Nano.
Nano, that's right. Git is what we're going to learn today as we dive into version control. And Nano lets us just edit a file, right? So it's an easy way for us to write code or make some changes to a file when we know we're going to want to do it inside this type of environment. So everyone's following along? Yep. We learned how to write a file from Nano. We learned how to exit. We learned how to read all the files that exist in a directory with ls. There's also ls-a. Does anyone remember what -a does? Does anyone remember how we would find out what -a does if we needed to refresh our memory? Estrella, what do you think what do you think it is?
By doing --help, it'll let you know what it does.
Let's do that. Okay, that was not helpful because I forgot to put 2 dashes. Perfect. So we get this help file that tells us a little bit about how to use the program. Let's just scroll up till we see A. So -a says all. Do not ignore entries starting with a dot. Well, that's interesting. So ls-a will show me all files, and now it's showing me that there are 2 magic folders. There's a dot and there's a 2 dot, right? Does anyone remember? We know that 2 dots moves you to the parent directory. What does the dot do? Does anyone know? Let's try that. Let's see what happens if I go to cd dot. Where did I go?
Oh, the dots is for to move to the previous or previous directory and to move forward to the next directory.
Close. Inside of Unix, 2 dots means the parent directory. 1 dot means the current directory. So whenever you see a command or if it says like provide the file name of a directory, and we're going to learn about this with Git today. A lot of things just assume that you want to work on the current directory you're in, and so they don't make you type stuff in, but you can always put a single dot and it will work on exactly where you're at. So we know that we can use pwd to tell us what directory we're in. So pwd tells us we're in C, users, me, test, but dot is exactly that same address. So what happens if we put it in? So we can. Here's a great example. So ls by default operates on your current directory, right? So if I type ls and I show this list of files that exist where I'm at, but I can also ls into a subfolder, right? There's nothing in there, is there? Nope. Touch. 1, touch. 2. Right, so I just created 2 files in there. So now I'm up in the previous directory, test. We can see that test2 is a subdirectory, and if I ls test2, it's going to show me those 3 files. If I ls-a test2, it should show me all the files that exist in test2, and you can see that test2 has a dot, and test2 also has 2 dots. The 2 dots inside test2 refers to the current directory we're in right now, just regular test. Okay? So, those are some of the main commands we learned yesterday. Nano, pwd, ls. Yeah, Andrew?
I'm just having an issue in my terminal. I'm trying to use the help option, like ls -- help, and it keeps sending me back. Ls is an illegal option.
Interesting. Would you mind sharing your screen so we can take a look?
Yeah, sure. Mm-hmm.
Let's we get to do some live debugging. This is always fun. All right, I see your screen. Okay.
All right.
Yeah.
So I'm
Perfect.
currently in my desktop.
So this is one of the weird differences between Windows and Mac, right? So we're using a program that lets us like emulate a Unix environment. You're on a Unix environment, and so your help option is probably the manual system. So how you would access your help, and this would apply to Estrella as well. You're also Mac, correct? Yeah. You would type man, M-A-N, space ls. So this is a much more robust documentation system. The Windows program that we're using to emulate your environment is just providing us some of that functionality that you get with a really robust documentation mechanism. And then to escape out of this, you can either press escape or Q. Yeah, perfect. Mm-hmm.
Awesome.
So
Thanks.
when you guys get into servers, into your career, and you're actually working on terminals, we can show that off later for sure. The stuff that you're seeing Andrew do on his screen is going to be very much very similar to what you're going to do on a Linux or an Amazon web server type of environment. So learning that man space and then the name of any program in the system is going to pull up a really good documentation system. For those of us working on Windows, we often get the -- help, right? There's always going to be little subtle differences. Every operating system has a slightly different flavor, so just be aware that, like, regardless of what system you find yourself on, whenever you're in doubt, if you type in man ls and it says unrecognized command or something like that, you can almost always go to Google and say, like, ls help on Linux or ls help on Mac, and Google will do a really good job of bringing you to those help pages as well, and it'll end up being almost identical. And just to show you, let's see, like Google, we can just search for ls help Mac. Right. See? Oh, here you go. It was an issue that was reported in GitHub because the Mac version of ls doesn't have that command. Cool. But you can go here and read the man page, which shows you all that same documentation. Great. Are there any questions on command line stuff that we covered yesterday, or do you guys just 100% got this? All right. Well, we're going to be doing a lot more of this, but today we're going to be learning about version control. So, yesterday we made sure, as a part of installing Git Bash for the Windows folks, we also took a little bit of time and installed Git on the Mac folks. Git, at its core, is a version control system. So why is this important? Why do you think version control is important? We touched on it briefly yesterday, but does anyone want to just summarize what you think about version control in general and why it's important to you in your career as a software developer? Leah, you're up.
And so that like you don't like one person doesn't make a change and then another person make another change and like the two conflict.
Yeah.
And so that like yeah.
That is one perfect example of how you're going to use version control every day for the rest of your lives. You're going to be working in a team. You want to make sure that Leah's work doesn't overwrite Wendy's work, right? And vice versa. That is one of the main benefits of using version control. Can anyone think of some other reasons that it might be beneficial? Andrew.
Just as far as debugging, rather than every time you save your version of the code, overwriting it, you have every version that you have saved, so you can backtrack and see each change in detail and figure out where something went wrong.
Absolutely. That's like a more advanced use of version control, and I'm glad you brought it up because I'm definitely going to touch on it today when we start learning a little bit about GitHub. There are some very powerful tools that you can use inside of Git that let you track down where bugs and things got into the system. So that's exactly right. Does anyone else have a guess of some way that version control is powerful to you? All right. Well, for me, right, regardless of if I'm on a team of 100 people or I'm on a team by myself and I'm doing work for myself, I'm always going to use version control for the number one benefit of version control. It lets me keep a copy of all the work I've ever done, from the beginning of a project through the end. Oftentimes, especially as software developers, even if you're not working on a team, you're not using collaborative benefits, and you're not debugging what you did a month ago, it lets me know that whenever I write code, that code is safe forever. If what I write this month is not useful, I can throw it out and go back to what used to exist last month. The version control part of this is the important bit, right? It lets us keep a record of all the work we've been doing forever, as long as we maintain good version control habits. There's a caveat, and the caveat being that version control depends on you being proactive. There are some products, some of you may have it on your computers. On Mac, they have Time Machine. Windows, they have like OneDrive that saves all your files into the cloud. There are products like Dropbox that basically you say, hey, watch this folder and keep versions of stuff. Those products are working behind the scenes, and they are like just making sure that whenever a file changes, it's going to store both copies. That stuff is great. Version control in the software development context is only going to act on what you tell it to act on. So if I'm working on a source code and I make a change, and then I make another change in an hour, and then I make another change, and then at the end of the day I save my work into version control, I've made like 15 changes that maybe I didn't track. So one of the habits that we're going to focus on quite a bit in this course is like, you can make small changes while you're writing code. Specifically, when you're in the middle of writing loops and functions and stuff, you don't need to be saving your work like you would. I don't know if anyone ever remembers, like way back in the day when technology was less reliable. Like I'd be working on an essay for school and I'd be hitting Control S all the time just to make sure that everything was being saved. So because the computer would crash and then you lose like 2 hours of work. You don't have to go that crazy with your source code when you're using version control. But it is a good idea that like whenever you add some functionality, whenever I write a function and it's done, I might commit those changes into version control so I can say like, this is when the function was added. And then I'm going to work on some more stuff, add 10, 15, 20 more lines of code, and then I'll commit it again. So whenever you get to like a good place in your work where you feel like you've added something to the code base that is important, that's a good stopping point to make you think, I should commit something. Okay? And we'll get into that, how to do it and all of that tonight. And for the rest of this entire course, as we're doing some software development, these habits hopefully should start to become instinctual to you, right? All right, so that is what Git is. So GitHub, which we're about to just take like an interactive break and start going to create accounts together, is a hosted version of Git. So what they did was they took Git, the version control software, which every one of you has on your computer, and they installed it on a server and put a really nice website around it. And so a lot of the stuff we're going to learn in the GitHub context is still behind the scenes just Git, but it's giving you a pretty web interface, and it's giving you a lot of the tools that are really hard to do from a command line, especially around reviewing code, working collaboratively. It gives you stuff like, I want to be able to take notes or comment on a coworker's code. All of that is provided very easily through GitHub. Now, GitHub is just one example of this. There are a bunch of other companies that provide version control software online, specifically Git. Bitbucket is another big company in this space, so you might go to a company that uses Bitbucket instead of GitHub. If you're using a different version control software like Perforce or Mercurial, you might use a different website altogether, right? This is just a tool, and as long as you learn the basics of the tool and how this fits into your software development journey, learning a new system should come as second nature to you. You should always, we kind of talked about it last night, which is like almost every company or every job you go to, you're going to learn new tools. They're going to be like, this is how we do things, and you just go along with it. But the concepts we learned today and then for the rest of this semester will be very similar regardless of what platform you're on, okay? They'll just have stuff in different locations, and it'll be different colors, and, that's the difference. So, Git is the version control software. It is the system we're going to use to control all of our versions. It's going to help us with collaboration. GitHub is a hosted version of Git that is online, that is really designed around collaboration. Okay? So, what is the best way to do this? So what I'm going to do is this. I'm logged into GitHub as me. And I have a whole bunch of stuff because I have been using GitHub for like a decade. I'm going to log out, and I'm going to create a brand new account. What I would like for all of you to do is follow along. So we're going to go to github.com.
Can you make it bigger?
The window itself, like the words?
Well, like it's the same size as all of our faces for me. I don't know if is it same for everybody else? Like it's that little one?
I don't understand quite what you're saying.
Yeah, I've been messing with it for the past 5 minutes trying to figure it out.
Yeah, same here.
If you click the pin, are you talking about in Google Hangouts?
Yeah.
Yeah, so if you click a pin on the window I'm sharing, it makes that window full screen.
Okay.
Does it look bigger now?
Yeah.
Okay. Yeah, another benefit of this class being online is that a lot of companies, especially ones that have moved to remote, are using Google Hangouts and Zoom all the time. So getting really comfortable and familiar with how classes work in Zoom or in Google Hangouts in our case you're gonna use that forever. So that pin will pin whatever screen you want, whether it's a specific speaker or if I'm sharing a screen, you are going to want to pin that so you get it full screen. Okay, so everyone can see this. It's big enough. Everybody's good. All right.
Yes.
I would love for you to follow along. So we're on github.com. We're going to sign up. It's going to ask you to put in a username. So you can pick any username you want as long as it's available. So I'm going to pick one that says CBC 12 instructor. Right? I can't put a hyphen. Right. So mine is going to be CBC 12 instructor. You guys should pick something that is professional-ish, right? Because this GitHub account should theoretically follow you around for the rest of your career. If you go to a company that's using GitHub, they're going to be like, what's your GitHub username? You don't want to have it be something like smelly farts, all right? You add a little bit of professionalism in here. Get used to this now. A lot of the tools we're going to be teaching over this course, it's going to follow you around forever. Especially because a part of the work we're doing in here is going to be a part of your portfolio. So you're going to be talking about the work you're doing in GitHub and for future employers. So let's all pick a good username, something that if you're a fan of chickens or something, you can be chicken girl, whatever floats your boat. But just try to keep it semi-professional. One cool thing about software engineers is I have found that in my entire career, it's a more casual work environment. People enjoy joking, so you can get away with a little bit more than you maybe could working retail or at a McDonald's or at a restaurant where you have to wear a button-up shirt. But let's pick a good username. Put in your email address. So in this one, I'm going to put in my backup email address. This might actually already be in GitHub. Yeah, it's already taken. Let's do GitHub at personal code. Cool. Pick a password. Okay. Good. It's going to have to be 8 characters with a number and a letter. You can have them send you occasional product updates if you want. This is really interesting. I've been using GitHub for forever. Every once in a while, they'll send you an email being like, hey, we released dark mode or something, which it's a feature you may want, and this is kind of useful to get. You're going to have to verify that you're a robot. What is a spiral galaxy? Hopefully that's it. Spiral galaxy. Good. All right, I'm not a robot. Congrats. And then create an account. So does everyone have an account now? Awesome. All right. So they're going to ask you a few things on this page. So you're a student, okay? But you can also pick, you're going to be a software engineer, whatever. Let's just pick software engineer. You have a little bit of programming experience. How do you plan to use GitHub? Select up to 3. We're going to learn to code. We're going to learn Git. And we are going to collaborate with a team. If you're interested in specific things, you can put some words in here. Like, I'm interested in JavaScript, right? That's an option. I'm interested in websites. Website. Okay? I'm just going to pick 2. All right? And then they're going to ask you to verify your email address. So once you've gotten to that step, you've given them a little bit of information about yourselves, go and check your email and make sure that you verify your account. So I will copy this link address, paste it into here. There you go. So we're all caught up. Let me know when everybody kind of gets to this stage. Yes, Andrew?
So I had previously set up a GitHub, but I want to change the email that it's attached to. Do you know if that's possible?
It is. What I have actually found is that I have a whole bunch of email addresses that I've had for years and years and years. If you just go into let me actually do it on my other one. Maybe it'll be easier to see. GitHub. Oh, I need to sign in. That's annoying. 2-factor authentication. Give me a second. All right. So here I am in my personal GitHub. If I go to your profile, where would it be? Settings for me. You can definitely change it in here, right? And then it tells you a link. You can manage your verified email addresses by clicking this link. So you can tell them, this is my email address. This is my work. This is my work address. These are my backup personal addresses, right? So when I go work at a job and they say we use GitHub, I'll often attach a work address to my GitHub account, and then as soon as I leave that job, I'll just delete it, right?
Okay.
Cool. All right. Any other questions? Are we all kind of caught up? We have an account at least.
Yeah, okay.
Gregory, I can't quite hear you. It seems like you're maybe a little far away from the mic.
Can you hear me now?
Yep.
Oh, asking, can you always change your username?
I believe you can. Yep, in your profile. Or I went to the wrong place again. Settings. You could put in a full name, a little bio. I think if you go to account, change username. Now be careful. The way GitHub works is that as you're doing software development, the whole point of GitHub was originally to support open source. So if you're writing a module or something, the username that you have is going to be the link to the modules you're building. So I would, as you get further along in your career, you probably don't want to change this. Otherwise, stuff that you've built that people care about might break. If you're not using open source, it's probably not a big deal. So they're telling you here that they're not redirecting. They're not gonna, if you make any pages, which we'll cover later on this course when we start building our portfolios, GitHub will also host websites for us. It'll be like, mine will be cbc12instructor.github.com, .github.io, something like that. If you change your username, anyone that cared about that other website would no longer be able to see it. If you agree to that, yeah, you can change it there, but it's under account. Anyway, and we are gonna, as part of this, when we get to the end of today, everybody is gonna give your GitHub usernames to me. I'm gonna add you to a Clubhouse repository, and then you're all going to be able to collaborate together through this entire semester. Okay. All right. So everybody's got an account. This is good. We're going to get back to what we do in GitHub later today. For now, we're going to start learning about Git. So, at its core, Git is keeping repositories, and a repository is intended to be thought of as a single project, right? So if I'm starting a project, if I'm at work, each project that the company that I work for has, right? If you got 10 websites, you're probably going to have 10 or more repositories. If you're working on a project for school, that would probably be a repository. If you start writing a book and you want to use Git to be version control for your book, you're going to want to make a repository. So think of a repository as a project, okay? By default, when you're working on your computer and you create a repository for the first time, that is going to be private, right? The only person that can access that repository is you. If you choose to use GitHub or one of those other services that we talked about, like Bitbucket or blanking on some names because I only use GitHub or Bitbucket, those repositories will probably, by default, be public, right? Especially on GitHub. GitHub makes the assumption that you're releasing software to the world. So when I create a repository in here, it gives me the choice right off the bat, public or private. If it's private, I'm the only one who can access it unless I grant others permission to see it. But by default, it's going to be public, and so that's something to be aware of. But on your personal computer, when you're working with Git for the first time, and when you're working on projects before you submit it to GitHub or submit it to Bitbucket, it will always be private. It's private to you. Okay? Is everyone clear on what a repository is? A repository is a fancy word for project. And it's called a repository because it's where all of your files are. It's a repository of that information, just like, it could have easily been called a library. They could have easily called it, older version control systems would call it like, we're not going to overcomplicate. It's a repository. A branch, and so this is where version control really becomes interesting. When you're first checking in files, and you remember this from yesterday when they asked us, what do we want to name our branches? When we were in, the default for the longest time is always to have the default branch be called master. But that has shifted over the last 2 years. Now the default branch is called, in a lot of different places, main. Back in the 1990s and 80s, when I first started in software development, all of our version control systems called the primary branch a trunk. And so they would call it this is the trunk. And if you imagine it as a tree, this is where everything goes. It's straight up and down. It's thick. And then when we branch off, it makes kind of an offshoot. And that's exactly what we have here today in Git. Even though the main repository is called main, you're still branching off to say, I'm going to go work on this feature, and when I'm done with this feature, I'm going to merge it back in, right? There's probably a really good visual that we can use. Let's see, Git branching diagram. Yeah. So let's just see what we get here. Yeah, this is a perfect example here. So if we just take a look at this, right? You've got our main branch, which they still call master in this version, where all of this is considered like the authoritative version of the source code. Most companies that are using Git or a version control system like this, if you've got let's say you're building a website, right? Your repository's main branch or your master branch is going to be what is live on production. So what your visitors see is going to be whatever this is. But as you're developing, you're going to branch off, and in this case, they're using a type of branching system that is like where they have a secondary development branch where they say, master is this is version 0.1, we're going to work from here, and as we build features, we're going to say this is a feature branch to add username and password box. When that work is done, it gets merged back into develop, and then they start testing it, and then it gets back into master once it's passed quality assurance. Okay, so this entire model, you can kind of figure that like the source code is chugging along right here, and as we're doing development, we're splitting off and then coming back in. Once it's been tested, it gives you a safe space to build stuff. You can write code that's broken. You can introduce errors. You can experiment. You can be creative. All of that can happen in a branch without breaking what's live on your server until you merge it back into master. Does everyone kind of understand that concept of merging? It's going to come up a lot. As a solo developer, it's easy to get in the habit of being like, I'm just going to work on the main branch and not care about branches at all. But when you get on teams, it is almost like required in every professional environment I've ever worked in to work from branches. So they'll be like, here's your ticket. This is what you're working on this week. You immediately create a new branch right off the main branch, and you start working in there. And until you're done, then you submit a pull request, and we'll talk about that in a minute. Okay. A fork. This is really a Git specific thing, but it's a GitHub specific thing as well. In open source, a fork is simply saying, I'm going to take a copy of whatever the current main branch of a repository is, and I'm going to make an entire clone of that repository. So, and we'll cover this in more detail later on because we're all going to clone off some stuff. But a fork is saying, you built a piece of software, I want an exact identical copy of that software, and then I'm going to do some development over here on my own, with or without you. That's a very common thing in open source where you'll see it. It's called a fork, right? And it's forking. Pushing, whenever you're working on a local Git server, so you're working locally, what pushing is that you're saying, this code that I've been working on is ready to go up into our main repository on GitHub. So you're going to push that code up, and it's going to be stored remotely. Pulling is very similar, but it's the reverse. It's saying, there's code on this server that I need to bring into my local development environment. So you're going to pull that code down. And then a pull request is you saying to the main server or to your team or however your team structure is set up, that says, my branch of code that I've been working on for a week is ready to go. I would like for you to incorporate that code into the main branch. Diffs, what a diff is saying, show me the differences between this version in this branch and this version in that branch. Okay? It's letting you evaluate what actually has changed between multiple versions of code. Git ignore is a special file that is going to exist on your computer that tells Git to ignore files that match a certain thing. So this will let you put in configuration scripts and configuration variables and not have Git try to save that into your repository. All right. So that's kind of like a high-level overview of all the main bits and bobs of Git. Okay. And a lot of these concepts, other version control systems like Mercurial, Perforce, they might use different words, but it's going to mean the same thing. So oftentimes, if I'm going to learn a new version control system, you're really going to want to search Google and says like differences between Git and Mercurial, and you'll find a website that shows Git uses forks, Mercurial uses whatevers, and you just learn the two words and you're good. Okay. Feels like it's time for some fun and exampling. You ready? Yes? All right. We are going to go into our CBC 12 folder that we made for our homework last night. So everybody CD into that wherever you are. Okay, and we're going to start learning Git together. We're going to experiment and play. Okay, so I'm in my CBC 12 folder. I'm going to change directory into my week 1 homework 1 folder. Okay, I've got 2 files in here. I got the screenshot I took for homework purposes, and I have the file that I made. I'm going to leave those alone. I don't need those, but I'm going to make a new folder that is called Git Repo. Right? Git Repo. In this folder, you can name it whatever you want. This is going to be our first repository. We're going to play around a little bit with it today. And then when we start doing actual development, there might be instructions that tell you what Git repo to use. There might be, as we work on class projects together, it might be bigger projects. We might all be working out of the same repo. But for now, we're just going to play with this folder called Git Repo. So If I cd into that new folder that I made, and I type git status, it's going to give us a warning because this is not a Git repository yet. Okay? If I type git init, this will create a repository. If I don't tell it any other words, it's going to assume the current directory. Okay? It's just like we were talking about the difference between 2 dots and 1 dot earlier today. It's the same as me saying git init this, git init dot. It would be exactly the same as me saying git init c users me test or CBC 12 week 1 homework 1 git repo, right? All of these commands, whether it's a dot or I put in a full path or I just leave it blank, it's going to create a Git repository right here in this folder. So as soon as I do it, you should get a message that says initialized empty Git repository in this location. Okay? And so really, behind the scenes, and this is something that's like super cool and you might want to become, super familiar with this. If I just take a look at the folder, it still shows up as empty. But if I do ls-a, which is going to show me all the files, including the ones that have a dot, you're going to see that it made a .git file. Okay? It's a folder. And if I cd into it, this is where all the magic of Git actually is happening behind the scenes. So when we're going to use the Git program time and time again, all of the stuff that it's doing, tracking versions, is all happening inside this folder. So if we cd into it, let's just take a look at what we got. So we have a file that says head. I can't use more. Let's just say tail head, right? This is a magic file that is telling Git itself, the program, the current version of this software is attached to this reference. We'll learn a little bit more about that as we go, but I'm just kind of giving you a high-level picture of like what all happens in here. Most of the time, you're not going to be in this file, and most of the time, you're probably not going to be doing any of this esoteric stuff. But you should be aware that it exists so that if something ever goes wrong with Git, which happens pretty often, when you start troubleshooting it on Google and maybe it's like, oh, my repository had a merge conflict and I've got stuff that's stashed, they might tell you to go in here and twiddle with some of these files, and so you need to know where they're at. You also have a config file. So if we look at the config, I don't know what this is all going to say. Yep, it's got core, repository format version. It's got stuff that tells Git how to behave. So there are other things you can do with Git that make it work for your specific workflow. Git is a very powerful tool. You can have it do all kinds of magic stuff, and when you work at a company, they might tell you what magic stuff you want it to do. Some things you can have it do is like, as soon as you check something into version control through Git, have it shipped off to some kind of program that will check your source code for errors. It will compile it and make sure that it passes all the tests. That would be like a post-commit hook, and that would be held in the hooks folder. There's a whole bunch of power user features in Git that if you're working on a really big project, for example, you might actually care about at some point in the future. But all of that is happening behind the scenes in this magic hidden folder called .git. If we go back up to the previous directory, which is our main Git repository, now if I type git status, it's going to tell me I'm on branch main. So it created that main directory we're talking about. Some of you on Mac, yours might say on branch master, right? Because I don't know if I don't actually know how to change that over to main, but we can figure that out later together if you want. It says we have no commits yet, and we have nothing to commit. But it also gives you a little hint. Yeah, go ahead, Gregory.
Mine still say this operation must be run on a working tree.
What does it say?
Fatal. This operation must be run in a working tree.
Are you still in the .git subdirectory? If so, you need to go back to your Git repo.
Yeah.
Yep, cd dot. And then type git status. It should tell you these three things, right?
All right, bet.
Got it? All right, cool. So it's kind of giving you a hint here. This is the next kind of step, right? So if we wanted to make a file, let's say we're writing some source code, we're going to make a cool video game or something. Let's say nano source.jpg. Right? So this is my source code file. I'm going to write a function test that takes no variables and it console.log hello world, right? So we're just writing our first little thing. This is our source code. We just got started. I'm going to exit nano. Does everyone see? Like, you can put anything in here. Like, it doesn't have to be a function. Just for the sake of argument, just type some gibberish in your text editor. And actually, let's do that just so we're all on the same page. Let's make a simple file that says line 1, line 2, line 3, right? Nice and simple. Then we're going to save it. We're going to call it source.js, right? And so now everyone has a file. We're all caught up to the same spot. We've got a file called source.js, and it's got line 1, line 2, line 3 in it, right? Sweet. All right. Excellent. So if I do git status, it's going to tell you there's still no commits. We're on branch main, and there is an untracked file. That means that Git knows there's a file in here that it's not watching. So if you computer died in the middle of the day and you need a new hard drive, version control has no idea that this file exists yet. Okay? So how we're going to add that, it's telling you. So we just try git add and then source.js. Okay? So now source.js is included in Git, and we can verify this by saying git status, right? But now it's going to tell you something different, which is this change, it knows has happened, but it has not yet been committed. So Git knows this file exists, it's watching it for changes, but if I was to recreate this repository, Git would not be able to give me this file because I haven't committed it yet. And the way we commit things is we say git commit, and then what I usually do is shorthand. There's another way, and we'll do this together just so you know how to do it. But git commit -m, and what the -m does is it lets me add a commit message. So if I do git commit -m source, we could just say initial entry, right? Because it's the first time we're adding this file. So, oh, perfect. This is excellent. Because we're using Git for the first time, it's probably telling everybody in here something like this, which is, hey, Git doesn't know who you are as an author. So we have to tell Git, I am Eric, and this is my email address. And the reason that's important is because when we're uploading this stuff to GitHub, when you're working on a team, GitHub needs Git to tell it that Leah was the author of this file, and here is her contact information. So it's telling you what to do. So we're going to type git config -- global. And what global does is it says, not just for this repository, but for Git itself. So if I make 10 more repositories on this computer, I'm going to use this same configuration again forever. So you only probably have to do this once, or in my case, whenever you buy a new computer, because your old one died. Git config -- global user.email, and I'll say, what did I say? Okay, just like that. So you're saying user.email, and then putting your email address in double quotes. Hit enter, and then you're going to do the other one. Git config -- global user.name Eric Harrison. Right? So now when I do commits, it's going to say Eric Harrison at this email address committed this code. Okay? Has everyone got that configured? Some of you might not. I think Max by default might like silently accept the commit and then get angry at you when you try to send it upstream. But running those two commands, git config global, I'm gonna store these so I can just paste them to you guys tonight, because they're useful and you will need to do them every once in a while. Git is usually pretty good at telling you when you've done something wrong. Yeah, go ahead, Andrew.
With the username, should that just be any name you want, like just my name, or should that be the same as my GitHub name?
Generally, yeah, I mean, you can do whatever you want.
Mm-hmm.
It's just a way of referencing you. There are some groups that work on open source where they use like nicknames. So like my nickname on the internet is Blister. I've been using it since 1992 when we used to chat in IRC. But from a professional context, as you enter your jobs as professional software engineers, it's almost always better to put your real name. So unless you're working on something secretive or something that, you know, maybe an open source project around cryptography and you don't want people to know you were involved in this, yeah, just put your name unless there's a reason not to. All right. So we've done that. Let's try git commit -m initial entry again. Okay, so now we're actually going to commit the file we've done. Is everyone caught up? And then we hit enter. And it says 1 file changed, 3 lines were inserted, and it's telling you that it created that file in version control. So now you know this is tracked forever. Okay? So if we do git status, it tells us on branch main, nothing to commit, because the software that we have in this folder is now completely up to date with what we have in Git. Okay? Is everyone following along so far? We created a file, we added it to version control, and then we committed it so that it's checked in. Okay? Any questions? Selena?
Yeah, I made a mistake somewhere on mine. If you want me to show it.
Yeah, let's see what you got.
Yeah, and entire screen. Okay. So I've got this here. And I've got that going on right there.
Hold on.
I missed a step.
I don't see your screen.
Oh, you don't see my screen. How do I, oh, there's this here. Yeah, and just share. Okay.
Yep.
Where'd it go? Okay, here we go. That right there.
So you need to run git add, right? It's telling you right there, use git add in the name of the file to include that in your commit.
So just like this?
Yep. And yep, exactly right. So now it's ready. If you type git status again, it will tell you that it's got 1 file that's being tracked that needs to be committed. So you see it says new file. Okay.
Okay, so it's good now?
Yep, and so now if you type git commit -m, you can just press the up arrow like 3 times. It will take you back to that last time you typed it in.
Just hit enter?
Nope, you have to put in the message, initial entry. Perfect.
Oh.
So now you're caught up. Awesome. So we've created a file, we've added it to GitHub, and we have committed it to our repository. So let's make another file, nano source2.js. Line 1 in second file. Line 2 in second file. Line 3 in second file. Right? It doesn't matter what you put in here. Go ahead, Andrew.
So I just realized I typed my email wrong. Is there a way to backtrack and edit that?
Yeah. So what you're going to do is type that exact same command. So if you've got a keyboard with arrow keys, you can just press up a couple times until you get back to git config global user.email, and then it's there. If you just correct your email and hit that, it's going to change the config. Or at least it should. Let's figure out if it works.
Seems like it worked.
Perfect. All right. So you're going to make a second file, source2.js or whatever you want to call it. Let's add a few lines, and it doesn't matter what you put in here. You can put gibberish, right, just to follow along. We just want 1 file to play with. We're going to save the buffer. Okay. So now we can see we have 2 files in here. If we type git status, it's going to tell you the same type of thing. This file is untracked. Okay. Now we're going to learn a new terminal command, and this command is cp. And what cp does is copy a file from one to another, right? This creates a clone. So we're going to copy source2.js, and then the second argument that you put is what you want the new file to be. So we're going to put source3.js. So this is going to make a copy of source2 and make it in source3. Okay. And if you hit enter, you should now see 3 files. Okay. 3 files. And if we do git status, you'll see that it's not saying source 1 because source 1 hasn't changed. There's nothing that we've done to source 1 since we committed it. But what we could do is edit source 1 and make a change. Wait, we just called it source, right? Let's add a 4th line. Line 4. Okay. Save it, yes. So now, if we type git status, it's going to tell us 1 file has been modified, 3 files have been added. Okay. So what do we got to do to add an untracked file? Does anyone remember the command? It's a git command. Go ahead, Leah.
Is it git commit and then -m and then?
That's very close. That is how we actually get. That's a stupid sentence. That's how we get git to save the work that we've done. But we need to add it first, and it's going to tell you it right here. Use git add file to do this. Okay. So normally, what we did last time is we do git add source2.js. We hit enter. Oh. Git add source2.js. That adds it. If we do git status, it will show us that 1 new file is being added, and there's 2 that have changes. One's a new file, and one is a file that it already knows about. Right? It already knows source exists. It does not know about source 3. So that's what it's telling you here when it says these changes have not been staged for commit, but this is an untracked file. There's a shortcut, so you don't have to type git add a bunch of times. And that shortcut ties into what we were learning about earlier, which is git add, and we can use dot. And what dot says is add every file in this directory that I can add. Okay? So if I do git add dot, it adds all 2 of those files that are still red on my screen. And it might not be red on a Mac, and it might not be red depending on what type of terminal you're using, but it's going to have very similar setup as this, which is going to tell you exactly what it's trying to do. So if we do git status, we can now see that 3 files have changed, and we need to do the command that Leah was talking about, git commit, and we need to say what is done. So just like before, we're going to do git commit -m, and last time we put initial entry, but this is the important part. As a software developer, this is a record of all the things you've done. And so what you put in between these 2 quotes is how you're going to know in a week, like, oh yeah, that was when I added those files. So you can say like, added 2 files and updated source.js. Right? Normally, you're going to want to put something that is descriptive of what you did. So you could be like, I added a function to update a user profile. Deleted a function that was broken, right? You're going to want to talk about what you actually changed, but especially in the early stages of projects, you're going to say like, this is the initial entry, added HTML.css, right? Like, it's going to be less descriptive of what you're doing and more like, I'm adding these files. But as we go and as we start developing real functional software, having a good record of what all you've done is going to be very important, right? And a great example of this will be, so you can see once we've added that, it's telling you, I've changed 3 files, and I made 27 lines be different. Okay. If we type git status, it's going to tell us, hey, everything is good. There's been no changes I need to worry about. Git status is going to be your best friend. Whenever I log into a server and I'm doing something at work, I'm almost always, before I mess with anything, going to say git status. What am I doing? Okay, so that I know where we're at, and I know what has been changed and what needs to be worried about, right? All right, so we've covered git commits. The one last thing I want to cover before we take a quick 10-15 minute break is git log, and this is why this is really important, right? If I type git log, it is going to display all of those changes from reverse chronological order that have happened in this repository. So this is like your quick and easy way to look at the history of things happening. Okay, so we can see git log. This was the message that I just typed in, added 2 files and updated source. That happened at this date. This was the author. As you start working on collaborative repositories, and there's a bunch of people on the team touching stuff, this is a really easy way to be like, yo, what did we do last week that broke things today? And you'll be able to quickly go in. I think it was Andrew that said this is a quick way to diagnose, who caused what and why is it wrong and who do I have to go talk to get it fixed. Okay. There are some other pieces of information on here that are very important. The first is it's telling you it's a commit. This long string of numbers here, letters and numbers, is hexadecimal, but basically this is a super duper unique string identifier of the commit. And we'll talk about that when we come back from break, about how this is used in the context of, like, if I needed to roll back a change and say, like, oh, these two files were terrible, we should undo that and go back to this version. This is how you would reference that commit so that you can go back in time. Okay. This commit specifically is telling you that this is the head. We were talking about that head file before. If we were going to go into, just like the head program, right? It's telling you this is the very top. So if you think of this as a big long ledger of all the changes that have ever happened, the head program that we use in our terminal to read the first 10 lines of a file is the exact same concept in this, which is this is the top. This is the very tippy top. So whenever you see the word head in the context of version control, it means this is what we're currently attached to. This is the most recent thing. And it's telling you that head is attached to the main branch. So we'll learn about a little bit more later today about branching and how this interacts with us, because this could show up with different words, especially when we check out new branches. But in the context of this, when you're working on a single repository with a single branch, you haven't done any crazy stuff, the top log is always going to usually be like, this is where we're at. But we could also check out an old version. It'll say, like, this line right here, head main, might be attached to this. And it's letting you know there's a change that happened later, but we're not looking at that right now. Okay? The one thing I wanted to show you with head, I don't know if you remember from earlier, but if we cd to that magical git directory, we've got this head file now, and that was there before. And if we tail head, it's still going to show the same thing. But if we checked out a different version of this repository, it would show exactly what commit that was attached to. What else is interesting here? If we look at tail dash, or let's open it with nano config. Oh, it's going to show it in the main one. Okay, that's a silly one. So when we're doing config dash global and we put our username and our email address in, there's another Git file that is like stored in the system somewhere, and it's going to be a different place, so I can't show it to you really easily because each computer that we have is going to store that in a slightly different area. But that has it'll say something like global in here instead of core, and that's where it's going to say user.email is this, user.name is that. So behind the scenes, one of the things that makes Git a really powerful tool is that everything it's doing in here is pure text. So you as a software developer, if you need to go in here and fiddle with stuff, it's very easy for you to play around with. It's also very easy to get yourself in trouble with, but if just know that it's a fun tool to tinker with. Okay, so we're gonna exit there. All right, so we've learned about Git status. We've learned how to create a new Git repository with git init. Okay, if you try to git init in a directory that already exists as a repository, it's going to give you some kind of error message like this. This one says reinitialized existing Git repository. I don't know what that means. It doesn't do anything. If we type git status, it's going to tell us we're working on up-to-date stuff. If we type git log, it's going to show us all the things we've done up till now. Okay. It is 6 o'clock. We've been kind of going at it for an hour. Let's take a 15-minute break. Kind of come back at 6:15, recharged and ready to get into like the fun stuff of version control. Does anyone have any questions before we go? All right, I'll see you guys at 6:15. Good. All right, cool. Everybody can see my screen?
Mm-hmm.
Sweet. All right, so we learned how to add files to Git. We learned how to check things in. We're going to, git add, and then the name of file, we'll add that file. Git commit -m, and then a message. We'll commit that file into the repository forever and create a commit log like this so that people can see what has been done and track it as we continue to do development. right? So let's just keep plugging along with this. Let's edit our original file, source.js. Let's say this file was written by Eric Harrison, right? This is like a fake comment, right? So I'm going to save it. I'm going to check get status just to verify where we're at. You don't have to hit get status all the time, but it's just a really good way, especially if you're taking a break. You're coming back. You want to see, where did I leave off? Get status will tell you, if you just stepped out for a minute, you went to a meeting. Get status says, you were working on this file. This is kind of where the repository is right now. It's a good habit to just get in the habit of hitting get status from time to time. We know now that we've modified source.js, so does anyone know what we would do to check that into the repository?
Will be git add in the name of the file.
Let's try that. Git add source.js. Okay. Get status. That worked. I don't know why it worked. Oh. It's because that's what we've done. We've changed a file. We need to add it. I was getting ahead of myself. So how do I make sure that this file that we changed is stored? What is the command for that?
That's git commit, right?
That is git commit.
Yeah, git commit.
And if I wanted to add a commit message, I would do that with -m, which is message, and I would put a thing in here. But if we don't put -m, what do you think it's going to do? Is it going to throw an error maybe? Let's find out. Let's explore together. What it's actually going to do is give you a full working version of your text editor, in this case Nano, where it's going to tell us exactly what to do. Please enter the commit message for your changes. This is really useful if you want a slightly longer commit message, right? Now I can do multi-line commit messages. I can be like, we updated the source file to include a comment about who wrote this software, right? So if we're doing something that's really big, we're releasing a major feature, when you get ready to do a final commit message, sometimes you'll want to just do git commit so that you can write a bigger message. Now, this is not always best practice, but this exists here for you as a way to be more descriptive, right? It's almost always better to err on the side of writing too much than too little, okay? I have many, many times been like, what the heck was this developer thinking? Only to discover that I was the developer that wrote that. I obviously made some kind of brain fart 6 months ago, and I didn't document it well enough to know where we're going. So you can do like a short little one-line thing, git commit -m, or if you just do git commit, it will give you a text editor, in this case Nano, and you can write it or exit and save. And it's telling you what file it's actually writing. So Git behind the scenes is saying we're actually editing this commit edit message file in that magic Git folder. Okay, but as soon as I do it, it's still doing the same thing as if we type -m. All right. It's telling you that it changed one file, it added 3 lines because we added a few lines at the bottom. And if I do git log, it's going to now show me, look, I've got a multi-line commit message that says we updated the source file to include a comment about who wrote this software, right? So this is the git log, this is the git process in general. You're always going to git add, you're always going to git commit, and then you have git status and git log to let you know what you're doing. Git status tells you where you are right now, and git log tells you what you have done. Any questions about any of that? Because it's about to get fun. Go ahead, Leah.
So when would you ever add something but not commit it?
Lots of times, especially when you're working on a big project. There might be 100 files in your project, and you're continuing to work all the time. You might write a new file, you're going to add it, you're going to when we actually get into the development phase, we're going to be running a web server locally so that while you're writing software, you can test it. You can add files all the time. You might want to add a file to test the value of something inside your database. But you're not going to commit it because you don't care. It's just a quick testing thing, or you're not sure yet if it's ready to be committed. When you do a commit, it's actually writing a log of all the things that have changed. It's storing it forever. But if you're just developing, you might add a file as you're working on it, but you're not ready to commit yet. there's lots of cases. The commit part, when you do the get commit, is actually what's writing that, in stone and saying, this is a change that happened between point A and point B. Okay? So another cool thing that we can do, and this maybe will touch a little bit on your question as well, let's make a change to that file, source that we've been working on, source.js, and let's go down here and say, this file was written by Eric Harrison and team, and we'll say copyright 2021, right? So we just made a simple little edit, but what this lets us do now is if we do git status, we can see that we have one file that's modified, and we know from our git log that we've checked in a previous version, but now we want to compare what has changed between right now and what used to be. So we can use a command called git diff, and if we type it by itself, it's just going to show you everything, or you could type it git diff source.js, and it will do one file. So I had 5 files in here. This will just let us look at one, but since only one has changed, it's going to show the same. It's telling you that it's got a whole bunch of cryptic stuff in here, but it's showing this line was changed. This is what it used to be. The red with a minus sign is the old. The plus that is green is the new. And your version on Mac might not have colors. You might be working on a computer that has different colors. All of that is editable or configurable, kind of behind the scenes. But by default, this is showing you that on line 4, it made this change. And it started on line 4. And it says, this file was changed to this line was changed to this, and this line was added. So now we can very quickly see these were the major changes. But this is really cool in that if I edit this file again, nano source.js, right? I can go in here and add something in between line 1.5, right? Secret line, don't tell, right? We're going to save it. Now if I do git diff, you can see that it says it added a line in between line 1 and line 2, and it removed a line and changed that other part. So the stuff that was there before is still there, but it also shows you a change up here, right? As you get to longer files, you're going to start working on source code files, and especially when we get into HTML and CSS, some of these might be hundreds or even upwards of 1,000 lines long. This can get kind of unruly. Luckily, GitHub and some other tools that we'll take a look at do a little bit better job of presenting this in a way that's easier to understand. One of the types of Git, or one of the types of diff that you'll probably see pretty often in your career, shows both versions side by side, so that you can this is the old and this is the new. There's also ways that on a Mac and some Linux computers and on Windows, if we really want to get crazy, though we're not going to do that, you can change this diff program and say, instead of using this diff program, when you type git diff, it's going to use this other program. Because I believe, diff source.js. So if I cp source.js into, actually, here, we'll just do this. This will be diff source.js, source2.js, right? This is using the same program, the diff program, which is looking for differences, and it can take any file combination you want. So when we type git diff, all git is doing is saying, take the diff program and run it on the current version in master and the current version that is there right now. Okay? So it's behind the scenes just running a program. The other thing we can do with git diff, if we go to git log, remember we were talking about these commit strings? We can diff other versions. And the cool thing about these numbers is they're so unique, you don't have to copy the whole thing. If I copy this whole thing, and I do Control-C, paste, you see I got the whole string in there. If I go up here at the front, and I do git diff this, I'm going to see a whole bunch of extra changes. So this was the version of the software up here, commit 48982, before we even included the original comment to add this file was written by Eric Harrison. So in this diff, the difference between the current version and what was the version 2 versions ago is that you notice that red line that was here that said this file was written by Eric Harrison and team. So if I do right, the difference between this and this is that this is looking at something two versions ago. This line did not exist in the version 2 versions ago. So when it gets to the current version, this is saying it doesn't even know that line exists in that old version. So it's just showing I just added it. Does everyone understand that? We're like looking back in time, and the diff tool is letting us compare what exists today, or what exists right now, with what used to exist. Cool. This is going to be very important, especially when you get into GitHub and when you start working on collaborations. We were talking about pull requests earlier, where you're saying, I worked on this feature all month. This is ready to be included in the main branch. Okay? It's going to create a pull request, which is basically saying, please bring this into the main branch, and it's going to let your team review your code looking at a bunch of diffs like this. And on GitHub, it's really nice. They use the side-by-side version, so it's really clean and pretty to look at. But behind the scenes, it's really just running this program. Okay? So git diff, that's a really useful one. Okay? So let's commit this. Git commit -m will say added copyright and team to comment. Okay? So we just oh, I forgot to add it. Git add dot, and then we run that same command. So because I already typed a command, but I did it out of order, right? I didn't add it first. It's telling me right here, there were no changes staged for commit. That means there was nothing ready to be written to this log. And then here, when I typed git add, it said nothing was specified, so we didn't add anything. Maybe you meant to type git add dot. Or I could have easily written git add source.js. So Git is kind of nudging me in the right direction of knowing what to do next. So whenever you're kind of lost, or you're like, I don't remember what I'm supposed to be doing, you can type these commands and it will hopefully point you in the right direction, because we're just really using git add and git commit most of the time. So now that I commit it, it has told us that it changed one file, it added 3 lines, and it took out 1 line. So remember what it was showing in the git diff? The minus sign meant it was taking that line out, and the plus sign meant it was adding these lines in. It's telling you here what it was doing behind the scenes. It added 3 lines and it took 1 out. Now, why do you think it's telling us that this line was taken out when this line is the same line? I just added some extra words. Does anyone have an idea?
Would it be that it took the line as a completely new line?
Yeah, essentially. Probably behind the scenes, it's thinking, one of the ways that you can check a program, and we might build something like this later on in the course when we're learning some of the JavaScript stuff. You can either look character by character, which is kind of slow, especially if you're in a program that has 1 million lines in it, right? There might be 10 million characters. Or you can just go line by line and say, is this line exactly the same as the other line? You can do that based on bytes. So they're probably just going as quickly as possible and comparing the lines themselves rather than the characters of the lines. So they say it's easier from a performance standpoint to tell you quickly that even though we know that this line just added 2 words, they are just saying, the Git program is just saying, let's just swap these 2. It used to be this, now it's this. Right? It's probably for performance reasons. Okay, so we're all caught up. Git status lets us know we're here. Now comes the super duper fun part, and you're going to do this all the time for the rest of your life. So what are the branches? We talked about branches before. What is a branch? Can anyone refresh the team? Wendy, what do you think a branch is?
I think it's like a place where you store everything, like after you, I guess, completed or committed a project, a repository.
Yeah, that's great. So you remember when we were talking earlier about this type of branching model? We're saying, right now we're working with 1 branch. In the Git model, we've got a main branch, so that's just 1. But what it lets us do is create as many branches as we want. So if we're working on a big team, everybody might be working on their own separate branch. So everyone can create branches and then work on it, and then merge it back into the main branch when it's good to go. So right now we're on the main branch, which used to be called master and is still master for those of you that are on Mac. But how we can take a look at this is as such. If I type git branch, it will tell us what branch we're on. Right now we're on the main branch. If I wanted to make a new branch, I would use the command git checkout -b, and then make a new branch. So we're going to make a new branch called test branch, right? So now it's saying we've switched to new branch, test branch. If I type get branch again, it's going to show us the branches that this system knows about. So it knows there's a main, and it knows there's a test branch, and the one that has an asterisk, and in our case on Windows, is green. That's the current branch. We can also see this if we type get status. It will see on branch, test branch, and it says there's nothing to change. Everybody follow along so far? You'll also notice our computer's doing this. I'm not sure if the Macs do this by default, but it's showing you in blue at the end of your file path here that we're on test branch. So it's just a really easy visual indicator to let you know, hey, you're not on main, you're on test branch. So as you're working, and as you're working professionally in the future, it's really important to not do stuff in the wrong branch. There is nothing that will make lead engineers that are on your team and are responsible for managing you more cranky than you polluting branches with commits that don't belong in that branch. And we'll talk about that later for sure, but just know it's important to know what branch you're on. Okay? You get that from get status, you can get that from get branch, and you should, in some cases get that here. The Macs, I don't know if they do by default. Andrew, does your Mac tell you what branch you're on? In the path like this?
It's just showing that. No, it's
Okay.
just showing I'm in just Git repo.
Yeah. So there are things we can do, and I do this pretty often on servers that I'm managing, where this is called git bash, because bash is the shell program that we're using. So it's the terminal the terminal itself is the program that lets you run this. It's a program that accepts commands and it knows how to read them. So Mac, I think, is bash by default, but there's a whole bunch of other shells. There's regular shell, there's CSH, there's ZSH, and depending on what type of server or system you're on, you might be on a different shell. On bash specifically, there's a whole bunch of configuration options that let you tie into Git and display things like test branch, which our program on Windows is doing by default. Andrew and Estrella could definitely set this up on their Macs, but that's probably a discussion maybe that's better suited for Fridays office hours if you wanted to have that kind of feature added for yourself, or you could do it when you're playing around tomorrow in the lab. I can give you some resources and you can go figure that out. All right, so we're on the test branch. We know we're on the test branch. Get status tells us we're on the test branch. Get branch tells us we're on the test branch. What do we do here? Okay, if we're working as a real professional developer, which you all will be very soon, this would be the scenario where you're working on a team and they say, hey, we need to launch a new feature. Please go off and build that, and when you're done, submit a pull request. So you go off, you create your branch, and you make some changes. We know that we have these 3 files in here. Maybe we need a 4th file, nano new feature.js, right? So this is the start of the new feature. Yay, right? And so you work on this, and you know that you also have to edit source.js because that's your main file for your project. And so you go in here and you add, we need, I went into Vim instead. Nano source.js, and you say we need to add this new feature needs us to add line 3.5 as well, right? So we've made a couple of changes. We've got a new file and we've made a change to an old file. And if we type get status, we should see that reflected. We see that we have a new file, we have a modified file. So let's add both of them by using get add dot, so we don't have to type them both out. Okay. Let's commit this change. Let's just assume that this was a really easy feature and we were able to knock it out in a couple of minutes. So we're going to commit it, and we're going to say final commit of new feature. Right? Great. So now get status shows us that our test branch is up to date. We can see in this repository that we have the new feature file, and we have the edit that we made to source.js. But main, our primary branch for this project, is still running the version that doesn't have this information. So if we use the git checkout command without the -b, because -b will create a new branch, but if we just say git checkout main, it says we switched to branch main. We can verify that with git status. We can verify that with git branch, which will show, hey, now I'm on main. We can also see our new file is gone And we can also see that if we nano source.js, it doesn't have line 3.5 that we just added, right? It has kept both versions completely separate. Okay? This is really powerful. You're going to do this forever. I will give you like really concrete examples. At any given time in various points of software engineering work I've done, I would have like 3 or 4 branches that I'm working on all the time. Main would be like our production branch, so that's got the stuff on the server. If a user reports an error on the stuff that's on the server, we might have a whole bunch of branches that we're working on for new features that are not ready to release yet. And so I'm working on those during the day, but some user came in and said, my credit card wouldn't work on your product. It gave me this error. I would check out the main branch, create a new branch to fix that error, and then check it back into main. And now I'm still working on my new feature in a separate branch, but during that time I made a new branch, merged it back into main, and launched that to the server so that my user experience wasn't disrupted. You're going to do that kind of thing forever. And you're going to do it regardless of if you're using Git or if you're using Mercurial or if you're using Subversion. This is a process you'll see time and time again. Regardless, in 10 years there's probably going to be some kind of new version control system, and we're all using, super version, right? Whatever it's called in the future. But you'll always do that kind of pattern, which is I'm working on a thing, it's separate, and when it's ready to go, it'll get merged back in. So let's verify that. We see that we're on main. We don't have that line 3.5, but if I see git branch, we know these branches exist on this computer, and I can check out test branch, right? So git check out, and then this is tab completed. So as soon as I start typing TES and I hit tab, it fills out the rest for me so I can type faster without having to type out the full word. So tab completion will be your friend from now until the end of the time. If I check it out, I'm back to test branch, and if we look at the files in our directory with ls, we'll see, sure enough, there's new feature.js. Okay? Does anyone have any questions? We went over branching. We went over how to keep them separate. We can make new branches off of test branch, right? So we can go like this, git checkout -b, because I'm in test branch right now, and I can say test branch version 2. So now I'm in a new branch called test branch version 2 that still has that new feature. So we can make branches off of branches. You really got it in your head, picture it like a tree where the main branch is kind of a trunk, and as we're working, you split off little, you got a big limb that comes off when you work on a feature, and then how this works is that you might build a new feature branch, and there might be a team of 3 or 4 of you that are all working on little components of that. Okay, so Leah might go off and build user login page. Selena might be working on the CSS so that the new feature looks pretty. Andrew's over there doing some kind of database thing. And Wendy is working on the JavaScript that makes buttons magically do things when you click them. Right? You guys could all be working together collaboratively out of one branch that is not live on production. It's not part of your main branch, but it's out of a feature branch that you're hoping will be ready to go in the future. Does everybody get all that? So think of it as a tree. And from the tree, you can split off any number of times. I can keep branching forever. And if I was to make a new file right now, nano, let's just echo warning. We'll call that to-do.text, right? So if we look at that, we've got a new file now. Git status will tell us that we've got a new file. Git add to-do.text. Git commit -n added a to-do list for the team, right? Now it's in there. Git log will tell us it's in there. And you can start to see that git log will start to get kind of crazy when you've got lists of like, okay, this was on test branch, this was on main. I think it's git log dash, let's say 3. Yeah. So yesterday we learned that when we were doing tail or head, those programs would accept a -n and then you put a number. With git log, it just wants you to put a dash number. I don't know why. It's just the way they wrote git. So if we do git log -3, it's just going to show us the last 3. If I did git log -10, it's going to show us the last 10. And now I got to scroll up to see all the stuff. I'm going to clear my screen with clear so that we can show that off really clearly. So I just want to see the last 3 commits that have happened. So Git is tracking all of these for us. We know that currently, my current folder that I'm in, because it says head points to this, is test branch version 2. which that's what this is. So the current version I'm working on is test branch version 2. If I check out, we remember that test branch version 2 has todo.txt. We just added that file. Okay? If I check out test branch, what do you think is going to happen to todo.txt? Gregory, what is going to happen to todo.txt? He must be AFK. Estrella, what's going to happen to todo.txt when we check out test branch?
Wouldn't it get lost?
Well, it's not going to get lost. It's just going to disappear from our current working directory. So if we ls, yep, it's gone. It's still there. It's still in test branch version 2. And now if we do git branch, we can see that we've got 3 branches on this computer. Main, which is our default, test branch, and test branch version 2. Test branch version 2 is the one that has it. If we do git log -3, so we just want to see the 3 most recent commits, we can now see that head is pointing to test branch. Okay? But it's also important to note, yeah, go ahead, Leah.
For some reason, after I did get log, like at the bottom it says like end, but it won't actually like I can't interact with it at all.
Try hitting escape. If that doesn't work, try hitting Q. Almost always one of those 2 buttons will.
Okay, Q worked. Thank
Q
you.
worked. Yep. So just get used to that. I mean, there's a whole bunch of programs that decide they were written by a whole bunch of different people over decades in some cases, and they just do things a little differently. You'll start to get used to them, but almost on a daily or monthly basis, I'm using a program or a tool. I've used it 1,000 times, but I hit the wrong button, and I'm like, what's the stupid command for that? It will become second nature to you, and eventually your fingers are just going to hit buttons on your own, and you're not even going to think about it. One thing to note, we're in test branch, so that's the one that doesn't have todo.txt. If I do git log, you see that it doesn't even know that that other commit exists. Does anyone have an idea of why that is? So you remember before, if we scroll up, when we were on test branch version 2, it said head was test branch version 2. When we go down here, it says head is test branch, which is expected, but it doesn't even know test branch version 2 exists. Yes, Gregory, what do you think it is? You're muted.
I had the answer, but I forgot it.
Oh, okay. Well, it's kind of counterintuitive, but the way that Git works on all these different files is that it's storing like a log of all the changes from the beginning of time until the end of time. In test branch, it's storing a specific log of changes inside of test branch. It does not know that test branch version 2 exists because test branch version 2 is a child of test branch. So until we either merge test branch into main, or we merge it into test branch, or we delete it or do whatever, test branch is its own thing. It knows main exists because main is its parent. It does not know test branch version 2 exists because it's like an offshoot, right? It's like saying the branch of this tree doesn't know that the leaf exists way down there. It just knows that it's attached to a trunk, right? Test branch version 2 still exists. We still might want to check into it and work with it, right? So we can still git check out test branch version 2, right? And if we do git log now, git log, let's do 4, right? It knows that it exists and it knows where it came from. But if it would be the exact same thing, if we made another branch off of test branch version 2, like a version 3.2.3 or something, it would not know that other one exists. Does everyone get that so far? Any questions? This is like kind of complicated for the first time. This is like definitely the most difficult new thing we've started learning, but you're going to do this forever for the rest of your life. And it's really important that you kind of are able to wrap your head around this type of branching model, because even if you don't use Git in the future, almost every version control system kind of operates on a very similar. There are exceptions, but in general, this is going to be pretty similar. Anyone?
Writing notes right now. Hold on.
I had a question just to go back from the beginning. So Nano is like I guess the editor that we're working in within it.
Yes. Nano is the editor we're using inside the command line. So you'll use it a lot of times for the stuff we're doing right now, which is like dealing with files on a server or dealing with Git. Because you remember if we did if we made a change to a file like nano source3.exjs, if we make a change like line 4 in third file, right? If we did just git add git commit without a -m, right? Nano is the default editor for this terminal, and so it's going to put you into Nano. Okay, it could be any text editor. When we actually start doing development, which really it kicks off for real tomorrow, we're going to install Visual Studio Code, and you're going to mostly work in that. The only times you're really going to see Nano is if you're on a server, or if you're just like when we're doing Git and we're committing our source code as we're developing on it. Occasionally, you'll need to just like, oh, what is this file? It's just a tool for you to be aware of, because sometimes you're going to have to edit something on a server or in a terminal like this, and I wanted to make sure that you guys weren't lost. Okay? These are just kind of like the fundamentals of being a software developer. This is some of the tooling you need to be aware of how to, like, if you got stuck in a terminal like this, how could you edit something? This is how. So yeah, added fourth line. So now our Git log is starting to get pretty messy, right? We're in test branch version 2, which you remember is a child of test branch, which is a child of main. So let's say we're done with test branch version 2. We say, hey, that's ready to be rolled into the main test branch. How would we merge that in? Okay, and I'll tell you the reason, the way to do it. Right. So first, if we wanted to compare the two versions, see what has changed. You guys remember the command for that? What is that?
Diff.
That's right. So we can do git diff. Actually, let's do git log -4. So we're gonna make sure that we're looking at the right thing, because now we've committed something else. If I do git diff right now, it's gonna compare by default this version to this version, right? Because that's the last commit in this like tree of commits. So if we do this, we're gonna see git diff. Do this. Boop. Paste. Shift insert. Is that a thing? So it's gonna basically diff those things, right? But you can also do by name. So I can do git diff head, or git diff would work if we had made changes that we hadn't committed yet. But we can also say, okay, test branch version 2 is ready to go. We want to compare it to test branch. So let's try git diff test branch. So it shows us that in version 2, we've added this file to do.txt, which we did, and we changed line 4. So if we think, hey, that's ready to go, now it's time to merge them together. Now, the way that we're going to probably do merges in the future is mostly probably going to happen through pull requests on GitHub. But this is the way that it's happening behind the scenes, and it's the way that you're going to work. If you're starting to work collaboratively and you're working on a project that takes a long time, you're going to do this pretty often. So we're going to check out the branch that we want to merge into. So in this case, git checkout test branch, right? We know that to-do.txt disappeared and we lost that change to line 4. But now we can do git merge test branch version 2. Okay, so that's going to say in the current branch I'm in, merge in this branch. Everybody follow me along? And because there were no conflicts, and conflicts is a whole nother animal altogether, it's going to say, I know exactly how to merge these two together without any problems. I'm going to add this file, and I'm going to make the change to this file. And so now if we ls where we're at, we can see that to-do.txt does exist, and new feature exists, or the line we changed in source 3 exists. Everybody following along so far? Yes, go ahead, Andrew.
So I was trying to commit something and I'm kind of stuck
All right, share your screen.
in
Let's
a
take a look.
screen.
I'll stop presenting.
So I was committing and then I forgot to flag it with the M.
Okay, yep. So this
And
is
so
perfect.
it brought me to this. So I'm stuck.
You are using Vim. Because when we were setting up our Git Bash, remember there was a question for all of us Windows folks that says, what editor do you want to use your default? The default Unix editor for the longest time since like the dawn of Unix in like the 1970s, right, is a program called Vim. And Vim is an awesome text editor, and it's my favorite. I love it all the time. But it's really complicated and really strange and super esoteric. So Vim is an editor that understands a concept of like flags, and so you're either in edit mode or you're in like do crazy stuff mode. By default, you're not in insert mode or edit mode. You're in do crazy stuff mode. So you can see down at the bottom it says insert. So the way to get out of insert is to press escape. Okay, and the way to write that file change is colon, so shift semicolon. You see how down at the bottom you got a little command thing, and you're going to type W and Q, which means write and quit, and then hit enter. So it did the exact same thing. You guys just aren't using Nano as your default editor, and we can change that if you want. I'm pretty sure you guys have Nano on here, right?
Yeah.
Yep, perfect. So we can change your Git to use Nano instead of Vim, and I'll circle back with you with the instructions on how to do that. Australia, you're probably going to need the same thing, right? But until then, all you need to know is for Vim is colon WQ will write and quit. And this is good practice for everyone else. On most Linux servers and stuff, everybody just uses Vim. And there's all kinds of jokes in this community. When you get a little bit further along in your career, you're gonna start seeing arguments between people that like Vim versus people that like Emacs, which is another crazy program just like this. It's a bunch of old people that have been doing computer stuff for far too long, and we've fallen in love with our tools. So I'm a Vim user because I know all the commands. There's a whole bunch of crazy stuff you can do, like using regular expressions to change entire blocks of code. All of that stuff is like way too advanced for the purposes of just teaching you guys how to be programmers. So we're not going to focus on any of that yet, but just know that you're going to get exposed to it at some point, and it's a lot of fun. And then you can pick your favorite editor, and you can talk smack to the idiots that like Emacs, because they're all wrong. So we're all caught up. You've made some commits. We are in test branch now. We just merged test branch version 2 into this. Now it's important to note that if you type git branch, you'll see that test branch version 2 still exists. Most of the times by default, Git errs on the side of keep everything forever. And as you're working on a project for months and months and years, right, you're going to have hundreds and hundreds of branches in here. And there are commands that you can do that will let you like quickly clean up old branches. But for the sake of the small projects we're going to be doing together, you can either leave them forever or you can delete a branch. And I believe, let me just make sure I'm telling you the right command. Let's look it up together. Delete git branch. I think it's git branch -d. Yeah. Yep. So if you do that.
I don't think you're sharing your screen anymore.
I am not sharing my screen anymore. Thank you for reminding me. But the recording caught it, and it's going to be a good video. All right. Yeah, so git branch -d, and then the name of the branch will delete it from your computer. If you want to delete a branch that exists on GitHub, or if we're using a remote repository, which we're going to learn in a little bit, you can force it to delete a branch by pushing a request to delete that branch. So that would be this. You'll almost never do this, I would imagine. I don't think I've ever done this. When you're in GitHub, when you're merging things, it will give you the option to delete a branch as a part of that pull request process. And we'll go over that in a little bit. But just know that you can do git branch -d and then delete. So let's do that right now with our test branch version 2. So git branch -d test branch version 2. So it says it deleted it, and you can do git branch and just verify this no longer exists. Okay. We do git log. What does git log tell us? It's going to tell us that what we've done is all of the commits that used to exist in test branch version 2 now have been rolled into test branch. Okay, so that's important. So all of the work that you did, remember when we were going back and forth between test branch and test branch version 2? Test branch didn't have any idea of what was going on in test branch version 2. But when you merge that branch in and you say, give me all the stuff that you did, it's taking all of the log as well. So these two commits happened on test branch version 2, and now they're a part of test branch. Got it? Behind the scenes, all Git is really doing is keeping a log of every change you're making. And when you do things like merges, when you do things like Git branching and things like that, all it's doing is saying, give me those log entries, and those log entries now belong to me. And it references those log entries by this crazy long number so that it's unique to this project. And in general, these are like super unique. So you might never see a commit message that that ever is the same ever, right? Because there's like 100 trillion options that can be in here. Another interesting thing is when you're referencing these, right? So we learned how to check out. So let's just copy a little bit of here, right? Actually, let's go to here. So we know main is here. So we could do git checkout main, which would take us right to this spot. But for the sake of just learning how you can play with these numbers, let's just grab a little bit of this. So we're just going to get a few of these numbers. Okay. And I can do git checkout and then those few numbers. Okay. It's telling me that I'm in detached head state. This is kind of scary. But what it's doing is I checked out something that is not attached to anything important. Okay. I can create a new branch from here, but if you needed to ever check out something that happened in the past, this kind of message is going to pop up for you. And you can see now that we're in this thing. So if I do git log, for example, I think it should, yep. So it's showing you that I've now forced my head to be in this commit, 2C905, right? Because we did git checkout 2C905, right? So you can check stuff out by just typing the first couple, you probably need 5 or 6 letters in here. But if I'm working on your team and I'm like, hey, can you check out 6849B6, right? You could just type that in and you'd be able to see what I'm seeing. And be like, look at line 10 of source.js. So this is a way that you can collaborate together. All right, any questions about that? Let's go back to where we were. Git checkout test branch. So we're going right back to where we were. And git log tells us we're good. So, test branch. We finished all this work. We've been working on this feature for a month. It's ready to go back to main. How would we get that back into main? What do we need to do? We know that we have 2 branches because we just deleted one. We've got main and we've got test branch. How do we smush the work that we did in test branch into main?
Wouldn't you just merge it back together like you did with the other 2?
That's exactly right, Estrella. It's the exact same process. Regardless of how deep we are, how many branches we've been working on, it's always using the same operation. Git, merge. And do we do that from test branch? Do we merge from here? Do we do git merge master or main? Excuse me. How do you remember where we have to be?
You would have to be in the master to merge it, right?
Yeah. Yeah, so you Mac folks would need to go git checkout master, and us Windows folks would be git checkout main. Okay, and then from here we do git merge test branch. And we do that, we see all these changes we've done in our feature development. So you can see very clearly, you can have this repository that has all of your source code that you've ever been working on. It's your website or it's your video game you've been working on. You can go off and build a feature. You can work with other people. You can fix things. You can delete things and undelete things. And at the end of the day, when it's ready to go live, you can go in and merge it, and it's going to bring in all those cool features along with it. Okay, and so now, can I see your screen? Can you? You cannot. Let me try stopping and starting it again. Could everyone else see it?
I could see it.
Yeah, I could see it as well.
Can you see it now, Wendy? Inside of Google, you might sometimes if you've clicked on somebody's head, you might have to click on the pin. Yeah. All right. So we've merged our test branch into main. Test branch still exists, right? We haven't deleted it. So often what you'll have to do is you've launched this new feature, you've merged it into your main repository, and now you need to like, oh my gosh, the thing we just built has a bug, right? The safest thing to do, or what you'll do pretty frequently, is you'll check out that current test branch, because main and test branch are the same now. But what you'll probably do is git checkout test branch. Go in there and you'll let's say there was an error on newfeature.js. So we're gonna nano newfeature.js. This is the start of the new feature, and we go to the end and we say we have fixed the bug. Right? We're gonna save that. So we fixed the bug in our code. We now know we can do git status to check where we're at. We modified it. We do git add new feature. Let's do it this way. We're gonna commit it. And we're going to commit it with -m so that we don't have to worry about figuring out what Vim does yet. So we're going to use fixed the bug the user reported. Okay, great. So now git status, we know if we type git log, we're going to see, hey, we just fixed this bug. Right? This is our most recent commit. But now we got to deploy that back to main. We've got to get it onto the server so that the server can work again. So we are going to go to git checkout main, and we're going to git merge test branch. Because right now, main does not know that you have that bug fix, right? We did it in a different branch. Main has no idea it exists until we merge. And now we see that newfeature.js has that bug. You would go and deploy it to your server, wherever that is, and hopefully now the problem is solved forever. All right. Now there's another way. Okay, remember we said we're going to go into the branch that we want to make changes to. Okay, so let's say we are working in test branch. Check out test branch, right? We're working on new feature. Oh, yeah, that's nano new feature. And we're adding more improvements to new feature, right? Yay. Because we're continuing to make changes to new feature. We've already launched it once. We're continuing to iterate over it over the span of a couple days. But while that is going on, there's another team in your company that is working on a new feature themselves. And they just launched it. And it's in main now, right? So let's go into, let's get checkout main, or get checkout master for you Mac folks. Okay? You'll see that if we nano new feature, we can see that it, oh, I forgot to commit it. Oh, never mind. This is a perfect example. So if we do git status, right? The fact that we've changed this file and not done anything about it to Git means that even though we checked out main, that change has followed us. So because we want this to only be a new feature that exists in the test branch, we need to recheck out test branch. Okay, so now if we do git status, we're in test branch, that feature we just added. Let's git add, let's git commit -m added a new feature for our users. Okay, git status. So now everything's clean. If we check out git main, or we git checkout main, okay, if we nano new feature, right, that third line we just added is not there because main does not know about the change that happened in our new feature file. Okay, great. But let's say there's a whole other team, and that whole other team is working on some kind of cool feature that like puts animated unicorns on the web page. So let's pretend we're that team for a second. We're going to check out our new branch. Git checkout -b will create a new branch, and we're going to call that branch unicorn feature. Right? We've made a feature where unicorns dance on our website. So this team, they're going to make a folder, and they're going to make dir unicorn images, and they're going to go into unicorn images, and let's find one on the internet real quick. Images.google.com. Unicorn art. Right? They put this image on their thing. So where's our folder? CBC 12. Week 1 homework. Git repo. Oh, I'm on the wrong monitor. You guys can't see me. So all I'm doing is I'm in this repo, right? Windows, I can see this. It has the unicorn images file. I'm going to save this image there into C users me CBC 12 week 1 homework Git repo unicorn images. So navigating your file system, you're going to do it all the time. Get very comfortable doing this sort of thing. So we're going to say this is unicorn1.jpg. Great. So now we've saved that file. We can see it exists here. If we go to our terminal and we type ls in here, we'll see now there's a unicorn. If we do git status, what is it going to tell us? Git status. It tells us there's a whole folder in here that we don't know anything about. So we need to add that. Git add. We can just do dot, or we could do unicorn images. But let's just do dot so it does everything. Okay, git status. And now you can see it's tracking everything. What dot does is says, give me everything new, which includes unicorn features, the folder, and the image inside of it. So now we need to commit it. Commit -m adds first unicorn picture for our cool feature. Right, great. So git status, right? We're in this unicorn feature repo. This team is so happy that they finished finding a unicorn. They've released this into the main branch. So we're going to check out main. Okay. And we're going to merge. So we're going to git merge unicorn feature. Okay. So that's the exact same thing we did on test branch and test branch version 2. But this other team working on the same project as you guys has just launched their unicorn feature. So it exists now. Right? And if we look at git log, we can see that their commit now exists. Main and unicorn feature are at the exact same place in time and history, and they've added a unicorn. So all of those repositories know that this file is there. Okay. If we ls it, you can see unicorn images is now in main. But if we git checkout test branch, if we ls, what happens? Unicorn images is gone because test branch branched off from main before unicorn features existed, and before unicorn features added itself back into main. So now test branch is off here floating off by itself. Does anyone have any idea how we can get test branch up to date with main when things have happened behind the scenes? First person to answer gets a Diet Coke at graduation from me. You're welcome in advance. Go ahead, Gregory. What do you think it is?
I'm looking at my notes that I've been writing down. I was thinking would be okay since branch is falling out. Would be best to add it back into the branch.
Which one? What command would you type to, like, if for whatever reason the folks working on this team were working on the new feature in test branch, we need that change that they made because we're going to use that unicorn in our new feature, and they're like, it's in main, it's ready to go. So what do we do to get it into here?
I want to say git a merge.
Okay, git merge, and then what?
Git a merge. The file name I'm thinking unicorn and merge that with the test branch or vice versa.
Yeah, that's one good way to do it, right? Because the unicorn branch is separate and is off doing its own thing, and We could definitely merge it by saying unicorn branch, right? We could merge in the unicorn features into here. Generally, what you would do?
Another way?
Yeah, well, no, you're correct in that this is the correct order. If we hit enter right now, it would slurp in that unicorn image because that's right. But how it would work in the real world, if that other team was working on features and they're committing it to main or committing it to master, what you would normally do if you're a team that's working on separate stuff is that every so often you would actually suck main back in because they already launched it to production. It's live. So you just want to keep your branch up to date with what's live in main.
Oh yeah, cause everybody gonna
Yeah.
send to the main
What?
one anyway. So might as well just do update everybody. Get
Yeah.
all this information an update from the main.
Git
All right.
merge is going to take whatever branch you're currently in, and whatever you say after that, and bring it on in. So your
Right.
way also would have worked. And I've worked in some projects and companies where everybody's kind of working off on a bunch of different branches, and when branches are ready to go, everybody kind of smushes them together. But in general, when you're working in a major company and you're all working on like a project, main or master or whatever your team calls their primary branch is generally treated as the source of truth. And so if you guys are working on a long project that takes a month or two or a couple of weeks, every so often you'll want to merge main back into your stuff so that you don't lose new stuff. Right?
So basically, to simplify it, every other branch is basically a rough draft, and the main is just the final draft or the final project.
Yeah, kind of. And that's
Right.
just by convention, right? So every single company you work at is going to do things a little bit differently. So in my current company, we actually do all of our development off of a develop branch, and they kind of show this here, and I kind of skipped over it, right? You can have any number of branches. So all the developers are working off this develop branch, and then like once every other week or so, we'll say, hey, the develop branch is good to go. Let's create a new branch and mark it with like 1.0, and then let's merge that 1.0 branch back into master. So we're creating releases specifically to go into a pristine directory, because as you work in companies, you're going to find, if you're at a bigger company, there might be other teams, like a quality assurance team that is testing your software that you've built between the time you've built it and between the time you release it to the production server. So the process will be different at almost every place and every project you ever work at for the rest of your career. And you just basically say, like, what is our development model? And they'll explain to you, hey, we work off of a develop branch. We have a QA team. Things go to a configuration manager. All this complicated stuff that we haven't covered yet. All that matters that you need to know is that in Git, specifically, every branch is basically the same. It starts off with a single branch when you create a new repository, and that branch is called either main or master. And as you build branches, each branch is just a version of things that have changed since the last time you made a branch, right? So if you continue to make branches, there's nothing special about main other than the fact that it was the first one that existed. So we could decide arbitrarily in like a year that we're going to create a new branch called production version 1, and then we're going to make another branch for a separate customer called production version 2 for General Dynamics. Okay, and they might be the same thing, but General Dynamics has a slightly different set of features. And so now you're maintaining two parts of a repository that was originally one. You can have any number of branches. You might be working on a team that's working on a test branch like we just did today, but every person on that team has their own stuff that they're working on. Like we had test branch version 2. Estrella might be working on test branch version 3. And you guys are all combining your work because all Git cares about is the changes that have happened from the last commit to the next commit. It's kind of complicated, but it's also kind of simple. There's only a few rules, and if you can wrap your heads around that, then you can do literally anything. You can conquer the whole planet with Git. You can write a novel. You can get a PhD thesis. You can create a cookbook. You can track your expenses and finances. Like, this is just telling you what has changed from the last time you hit save or commit, in our case, and this current time. And if you make a branch, it's saying, give me a copy of that thing at this time, and I'm going to work over here until I decide to merge them in. Everyone get it? Are we all at this stage right here where we're merging main into test branch. So the reason that this is doing this like this is because these are two separate branches. When we merged them the previous time, when we went into the unicorn branch, and when we merged this other stuff, Git was smart enough to know, like, hey, this branch was later in the future than this other branch, but because it's the reverse this time, unicorn branch happened after this, it's giving us the option to make we're going to make a commit message that's going to say that, like, at this point in time we were working on test branch, everything was going great, and then we chose to make test branch have stuff from main. So it's continuing to preserve that history of all the changes, right? So if we write, right, before when we did this, it said this git merge unicorn feature. It was doing updating, and it was saying it's moving this commit into this commit, and it's doing it by fast forward. But because we were doing it, merge was made by recursive strategy, not fast forward strategy, it made us do a commit. And so if we do git log, it's telling you that now there's a commit that says test branch is this address, and we kept that commit message. We could have changed that commit message, but this is the default. We could have said merge branch main into test branch so we can have the unicorn pictures. Okay, this is entirely up to us what we put in these commit messages. And as I mentioned before, we want to make this as clear as possible so that in 4 or 5 months when you're working on this and you're like, when did we get those stupid unicorn pictures in here? We can point back in time and be like, oh, it happened right there. It was when we merged main into test branch, because that was what added the first unicorn picture. Now, when we come back after a little break here in a minute, we're going to start working in GitHub, which provides a lot better tools for seeing this type of work. Okay? You'll be able to see, like, when did this line of code change, and you'll click a button that will give you a message that says, this was added by Eric on this date, and here was his commit message when he added that line of code. And that's a lot of fun. It really helps you dive into, like, how things change over time. Okay? Does anyone have any questions on this before we take a quick little break? It'll probably end up being our last break of the evening. We've covered a lot so far, but this is super duper critical because you will literally use version control for the rest of your career. And trust me when I say, even if you don't get it today, you're going to do homework on it tomorrow, and you will use this almost every single day for the rest of this course. This will become like breathing to you, and I promise you that you will get it 100%. Gregory, did you have a question?
Yeah, will you post the video on Slack or Google?
I'm gonna have to upload it to YouTube overnight. I will probably paste it in Slack. I don't know where we're gonna store these videos long term. I know that previous classes had a Code Bootcamp playlist where they covered all the videos that have been done. I have to find out if I have to get access to that. But I will post the links to each session that we record somewhere that you guys can find it. I just don't know where that somewhere is yet.
Okay.
All right. Any questions about all the stuff we've learned so far in Git? So far, we've learned how to add things. We learned how to create a new repository. We learned how to add, switch between branches and create branches. We learned how to delete a branch. We learned how to merge stuff in. In general, those are like the 5 or 6 things you're going to do on a daily basis. And, the extra bits would be like git status, git diff when you're wanting to look at what was different between what I'm doing now and what I did yesterday. You'll use that probably less frequently than some of the other stuff, especially once we introduce GitHub, but it's just important to know that it exists. Another thing I'm going to post tonight is a Git cheat sheet, which kind of goes through all these commands, explains what it does. For at least the next couple of weeks, I would encourage you when we're doing homework and stuff to just have that up, have it in the background, put it in a tab on your browser, just so you can be like, I know we talked about it, I know it's git commit, but do I use -m or -n? There's a whole bunch of different flags. So I will post that as well. It's a good resource. I use cheat sheets all the time, especially when I'm learning a new editor or a new language. So it's a good habit to get into. When you're learning something new, keep a quick reference guide. Take notes to yourself if you're the type of person who likes to write and take notes. But if you are use resources that are already available. There are a lot of smart people who've done all this before, and they've made tools for you to be easier. Any questions about Git before we move on to GitHub after our break? Going once, going twice. All right. It is 7:22. Let us regroup at 7:40. Okay. That'll give you time to stretch your legs. We've been sitting for a while. We've been using our brains. 7:40. I'll be back at my desk at like 7:30. So if you have any questions or if you think of anything, I'll be here. Don't hesitate to reach out. But 7:40, we'll come back well rested, well hydrated. Go drink whatever that orange drink was, Estrella. That looked cool. And we'll see you in a bit. All right. All right. We're live. All right. So GitHub. Now we've learned the basics of Git. We know how to work with files. We know how to work with repositories. We know how to branch. We know how to merge. Working collaboratively usually requires some kind of remote Git hosting system. So in our case, we're going to use GitHub. You might use it in your next job. You might use something else like Bitbucket. They're all doing basically the same thing. They're just hosting Git and putting a really nice, shiny interface website on it. We have to do one more setup step with GitHub. We spent all that time earlier this afternoon setting up our accounts. We have to authorize our computer to connect to this GitHub account, and we have to do this kind of in a weird, esoteric way. Everyone that's on Windows, there's a shortcut way to do this, and I'll just briefly explain it, but we're going to do it the old-fashioned way because this works for Mac, this works on Windows, this works for older versions of Git Bash, this works if you're working on a server. This is the correct way, and you're going to, while there's a fancy new way for GitHub, this old way will also work on Bitbucket and will also work with other version systems. So what you have to do in your GitHub is go into Settings. So you're going to click the top right thing, go to Settings, and you're going to select SSH and GPG keys. So one of the things that Git and GitHub is doing behind the scenes to make sure they're doing things securely is all the files and source code that you're going to upload is going to be done through an encrypted channel using a protocol called SSH. SSH just stands for Secure Shell, and it uses cryptography behind the scenes to make sure that everything is encrypted and that when it gets to GitHub, GitHub knows how to unencrypt it. Now, we just created our accounts, or some of you had an account already, but we probably don't have any SSH keys in here. So you can see it when you click on this SSH and GPG keys. It says there's no SSH keys associated with your account. If you ever get stuck in this situation, you get to your next job and you're like, I did this 4 months ago, but I forgot all the things we did. This website is really good about telling you what to do. I mean, let's just open this in a new tab. So we would want to click on this middle link here, generate a new SSH key and add it. All right, and so it's going to tell you kind of what to do, and we're going to do some of this. I don't know what this ed25519 algorithm is, so we're not going to do that part. We're going to probably do this one. Okay, and we probably aren't going to use the -c. But what we are going to do is take SSH keygen -t RSA. We're just going to copy that part right there. Okay. This up here is probably more secure. If this is what they're telling us to do, it's probably the better way to do it. But since I don't know if the Macs that you guys have will work on this, and I don't know if our current version of Git Bash will work on this, we're just going to do the thing I know works. And we can experiment with this and see if it will work as well, because you can have as many SSH keys as you want in your GitHub. If I showed you my GitHub right now, you would see I've got an SSH key for all of my servers that I've got, so they can all communicate with GitHub. I've got an SSH key for all the computers I have floating around, laptops, tablets, all kinds of silly nonsense. But we're going to take this specific command, this line of code right here, and we are going to bring that over into our thing, our Git Bash. Right? So we're going to do SSH keygen. On Windows it's .exe, but really, I mean, on Mac it's just running the program. -t RSA. Okay, got it? And as soon as we hit enter, it's going to say it's generating a public and private RSA key. So it's creating a cryptographic key that only our computer knows, and it's going to ask you where to save these keys. And so on my computer, it's saying it's storing under C users me .sh, a hidden file, and ID RSA. That's perfectly fine, so I'm just going to hit enter. It's creating a directory, so it did that. Now it's asking me to enter a passphrase. So if you wanted to be super secure, some of your employers are going to require this. They're going to want you to put in some kind of password here. Generally, if it's my computer, I'm the only one who ever uses it. It's my server. You know, I'm just going to leave this blank. This is not best practice in terms of security, but it is quick and efficient, right? You don't want to spend all day typing in passwords if you're an active developer. So do whatever your future employer tells you to do, right? I'm going to hit enter. It asks you to verify because I don't have a password. I'm going to hit enter again. And it's telling me I have created this this SSH key, and it gives you this little cutesy picture that it generated. I don't know what the cutesy picture for, but it's always going to be unique to you. So your cutesy picture is going to look different than my cutesy picture, okay? Has everyone caught up to that stage? Because now we have to do a second step. I'm going to assume we're all good, all right? What we need to do is whatever this folder is that it created, we need to copy this. So if you're on a Mac, it's probably Command-C. If you're on a Windows, it's Control-C, but it's easy just to right-click on that and go to copy. And then we're going to change to that directory. Right? So CD, and then paste that path in. Is everyone following along? Please stop me if we're going too fast, because we got to do this exactly the same, or you won't be able to communicate with GitHub, and nothing else will make sense, and we'll have to fix this later. So, everybody good?
Yeah. My key is not working.
Which part?
When you add a new key and you keep it blank.
All right. Why don't you share your screen and see? We'll see what you're looking at. Oh, we're in the console. Yeah, you got to go to the terminal. So pull up your bash prompt.
The console.
Yeah, it's the little black program we've been typing in all afternoon. That's your console.
Oh, you're talking about
Yep, your git bash.
Yeah, the git bash. Okay,
Yep.
bad.
Pull that up. And then when you're in git bash, let me share my screen again. You're going to type in this phrase exactly. SSH-keygen space -t RSA. And then hit enter, and it's going to say generating public-private key. It's going to ask you where you want to put it. You can just hit enter for the default location. It's going to ask you for a passphrase. You can leave it blank. Just hit enter. It's going to ask for it again. Hit enter. And then it's going to create it. So you should see after this.
Okay. I thought we were doing this in GitHub.
Nope. GitHub is where we're going to paste the key that we just generated. So we've created a key, and we're going to tell GitHub, this is how you communicate with us.
We're basically making a remote access to GitHub to what we're using right now.
Yep, it's telling GitHub, we're going to encrypt everything we send to you, and we want you to encrypt everything you send to us. And here's the secret message that we're going to use, like a decoder ring. If you guys ever saw like that one Christmas movie or whatever where they get a decoder ring and it says drink more Ovaltine, we're making a private, secure channel for us to talk to each other. So,
okay.
Once you've gotten to this stage and you see this little cutesy picture, we're going to copy this path. Your path is probably going to be different. You know, the Mac folks is probably going to say /home/ whatever your username is /SSH or .SSH. So we're going to CD to that path. Okay. And now, CD C users me .SSH. Okay. So don't include IDRSA at the end of it. It's just .SSH. That's the end of the path. Because in that folder is IDRSA and IDRSA.pub. Is everyone at the same step as me?
Okay, I got a picture and the dash bash.
Are we all at this step where we've just changed directory into your .ssh folder? Yes, is good? All right. You see there's two files in here, IDRSA and IDRSA.pub. Okay, I'm recording this. I'm going to show this to you for posterity, and then I'm going to delete this later on. because IDRSA is your secret key. If anyone has this, they can decrypt your communications left and right. They can steal your bank account, and not really. They can decrypt the communications between you and GitHub. IDRSA.pub is perfectly fine to share. This is the type of file that you are going to give to GitHub. You're going to paste it in that box. And this tells GitHub, hey, when you're sending stuff back to me, you can decrypt it using this public key, or you can encrypt it using this public key. This IDRSA.pub is going to be structured very similar. Tail IDRSA.pub, or IDRSA, and we'll do N20. I don't know how big the file is. This is, yeah, I gotta do even more. 200. Let's do 200. This is actually the secret key. You can see that it says begin OpenSSH private key. This is what the key looks like. So behind the scenes, when you're encrypting things, it's using this crazy string of random letters and numbers to encrypt that communication. But all we care about right now is the IDRSA.pub. So you want to tail that file and then copy the entire string up until the end. So Mac Command C, Windows Control C, or you can right click if you got a mouse and click copy. Okay. Then once we've got that copied into our clipboard, we're going to go into GitHub, click new SSH key, and we'll add a title. We can just say like my PC, right, for the title. And inside this key box, we're going to put Control V or paste, or however you paste on your computer. Okay, it's going to look exactly like this. When you're done, you click Add SSH key. So now you can see that we have one key in here. If we ever need to add more, we get a new computer, we get a laptop, we get a server, we're going to come in here and add new keys. It tells you this has never been used. It's a read and write key, so it can both write to your repositories and it can read to them. So anybody who has your key, and that's why we don't share our IDRSA key or ever, is that anyone who has that key can, in theory, put stuff in your source code repository and make it look like it was you. So, you know, there have been data breaches in the past where someone gets a hold of one of these secret keys and uploads malicious code into the software for, you know, Facebook or Google or any of these companies that use systems like this. Okay?
Quick question.
Yep.
How you can change the SSD to only to read?
Great question. I don't know if you can with this. GitHub, I don't know if they have controls behind the scenes that say this is read-only key. They might. I know some services do. When you add a key this way, it's a read-write key, and that's so that you can both pull stuff from GitHub and send stuff to GitHub. You have to have both. If you're working on a team, you have to be able to read and write, right? So now that we've got that set, now we can go back to our terminal, git bash. Okay, we're going to go back to our project folder. So wherever you've got that stored, I'm just going to press CD. If I hit CD with nothing, it's going to take me back to my home directory. It's going to probably do the same thing for everyone on Mac. It's going to take you to your /home/ whatever your name is. But for me, it's taking me to my home directory, and then I can go straight into CBC 12, and then I can go into week 1 homework, right? Because this is where our project folder was. So I can go into Git repo. So now we're back exactly where we were, right? Now we're still in test branch, so just for the sake of learning how all this GitHub stuff works, we're going to check out main. Okay. So now we're exactly where we were at the beginning of the day, but we've added all these new features, and now it's time to start working as a team. So we're going to use GitHub to do that. Inside GitHub, if you just click on this little octocat up in the top left, it's going to take you back to your main dashboard. Everyone in here should see something very similar to this. Yours might be white. Yeah, go ahead, Andrew.
I was just going to ask if you could slow down for a second. I'm trying to catch up.
Yep. What step are you at?
I've been having a few problems with my terminal in general. It's like with autocomplete, and I was maybe going to ask later, but it's just even trying to get back to that directory.
Okay.
I don't know why it was.
Yeah, so if you type CD and hit enter, it takes you back to your home directory, right?
Yeah.
Okay, and then from there, I would assume you've got your CBC 12 directory directly under that, right?
I should, but it's not.
I had to do CD desktop, and then it was in there.
Okay, so you put yours on the desktop.
Yeah.
Yeah, great.
Okay, that could have been.
One thing that I do promise you is that I know that a lot of this is super new for a lot of you. As you get exposed to this over the next 12 weeks, you guys are going to be flying through this file system like the back of your hand. You're going to know your computers, the folders and the directory structure pretty well, because you're going to be typing these commands over and over and over again, like on a daily basis. Okay.
Gotcha. Okay, I'm caught up. So we should be in Git repo, right?
Yep. So you're back in
Cool.
week 1 homework and then Git repo, right? And it should
Yep.
be you should check out the main branch. So if you do git branch, or if you're on test branch right now, we want to do git checkout main, or in your case master. Git checkout master. Okay.
All right.
Great.
We're good. Sorry.
No, is everyone else caught up? We're all at the same spot. Thank you for stopping me, because I'm just kind of flying along. But I can't see your screens like maybe we could in a classroom. So that's exactly what you're supposed to do, and I appreciate it. Everyone else good? All right, so we're in GitHub. Wendy left us again. Hopefully she'll rejoin in a second. I'll give her a minute. This is important, and I don't want her to miss it. What's everyone's hobbies? Gregory, what is your hobby? What do you do for fun?
Rock climbing.
What was that?
Rock climbing. There's a rock climbing gym.
Rock climbing?
There's a rock climbing gym near I think not Georgetown. It's called Active Rock Climbing.
That's super cool. Rock climbing is awesome. I am not strong enough for that.
Yeah, it's called Active Rock Climbing in Augusta. Looking where it's at. It's quite interesting.
Nice.
Yeah, it's near Grovetown, Old Blair Road.
Very cool. I'll have to check that out. I don't think I'm strong enough for that. Selena, what do you like to do? What's your hobbies?
Xbox.
Nice. What games?
Right now, the new Mass Effect.
Oh, cool. You liking it?
Yeah, I never played any of the old stuff.
Cool.
I was a noob until I married my husband. So I've only just playing video games the last 10-ish years.
Excellent.
So I've been working my way up, and now I'm good enough to play Mass Effect.
I've heard good things about that series. I haven't owned an Xbox for quite a while, so I haven't been able to play, but it's supposed to be really fun.
Yeah,
Estrella,
it's
what do
fun.
you do? What do you do as a hobbies?
I'm not sure if it counts, but because of the bartending, I really do like to make new drinks. I can
That's
mix
very
some things
convenient because
together.
I like to drink new drinks, so it's very similar.
During quarantine, we set up a speakeasy at my studio apartment in Phoenix. Like, set it up. We all had like outfits and everything, and we made this drink called a Lady in Red. It tastes like a cherry slushy, but alcoholic.
That's awesome. Andrew, what do you like to do?
I golf a lot. I love to golf, and then
I'm a terrible
running.
golfer, but I love it.
And then running. I like to
Okay.
run.
Cool. I used to run
Quick-
in the Army, and then I didn't like it ever, so I don't. Leah, how about you?
Quick question.
Yeah.
Sorry, what portion of the GitHub page are we on right now?
We're just on the main, if you're just at github.com. Yep.
Gotcha. All right.
And yours is probably, all of you are probably, you have the white version. So I think there's an option here in settings. You can choose light mode or dark mode. It's under appearance. And so it's day theme, I guess. And mine is just choosing this based on sync with system. So I have dark mode set up in Windows, and so it's reading that. But you can choose either one. Anyway, Leah, what's your hobbies?
I like video games.
What do you play?
I really like VR games, like Half-Life Alyx. Like, I bought a whole VR system just for that game, and like honestly, it was so worth it. It's really cool.
That's awesome. 2 jobs ago, I worked in an education company. We built simulations for the government, and so we built a VR game using Oculus that trained various government agencies on how to do like surveillance missions. And so one thing that we did that was really cool was we spent a bunch of extra money. There's a company overseas in Sweden or Finland or something that will modify the Oculus and put little tiny cameras on the inside that look at your eyes, and so it will track what you're looking at inside the game. And so we had a whole bunch of stuff that was like, if you make eye contact, you fail the mission, right? Because the bad guy's not supposed to know that you're watching him.
Oh, that's amazing.
It was fun to build, and I also am done with video game development because it's a stressful way to be a software engineer. So, but it's a lot of fun.
Really is.
Everyone should do it once if they want to build games.
I've always heard crunch is like especially bad in gaming.
It can be.
Yeah.
Sure.
Yeah, it was. I was reading on comments on Cyberpunk 2020 because they want to release it later on, but they got forced by whoever the head director or the stock market shareholders was trying to force them to release the game early instead of just waiting until they finish.
Yep.
It's crazy.
That happens all the time. Business needs come into conflict with what actually needs to happen on the ground as developers. You'll see that your whole career.
Knowing that.
Yep.
Knowing that. Oh, go ahead.
I was just going to say, it doesn't look like Wendy's going to be able to rejoin quickly, so we might as well dive back in. She can hopefully watch the video and get caught up tomorrow. As for me, I play Rocket League. On Mondays and Wednesdays, I'm in a competitive league. That's my favorite video game in the whole world. I've been playing for like 5 years. I'm crazy good at Rocket League. That's my favorite.
That's so cool.
All right. Cool. Do you got Steam?
Yep.
Yep.
All right.
I'll play you later.
So here we are. We're in GitHub. We're going to create our first repository. So we already have a repository. It's on our computer. But we have to create one on Steam, or on GitHub, so that it knows, so that we can sync them together and we can start putting our code upstream. Now, generally, when you guys start working on a project or you go to a company, your first step is going to be not to work on your computer, but to work on GitHub. So you'll probably almost always either have a repository already up here, like if you're going to a company, or you're going to just create one here and then bring that repository to your computer. But because we have a repository already, we're going to go the backwards way, which is we're going to assume that we've been working on this for a little while, and we're going to create it here so that we can then upload it and link it. So what we're going to do is click Create Repository. Okay. This is the reason why it asks you to be very careful when you're changing your username, because the URL to your repository on GitHub has your username in it. So if you were to go in and you'd be working on this for months, and then you decide, my username was inappropriate for work, I need to change it, right? Now all your repository links no longer work, and you have to fix a bunch of stuff. So what do we call this? We call it Git repo. So let's just give it the same name that we've been using for our folder, just so things are simple for us to keep track of. We put in the name. It's going to say that it's available because all of these repositories are unique to us, our user account. Okay. If we're in any other teams, which you guys are all going to be on a Clubhouse team that we're going to create for this class specifically, you might see other options in here. The longer you're working on GitHub, you'll end up finding yourselves in, like, you're going to work in a hackathon, and then you're going to work at a company. You're going to see a whole bunch of things in here that give you options to choose who owns the repository. But for now, if you're just creating an account, it's probably just going to say just your name. You put in your name. You can put in a description. This is generally just like on the GitHub page itself. So if someone comes in and looks at your content, they're going to say, oh, this is the repository that does X, Y, and Z. So we're going to say first repository to learn Git. Okay, easy peasy. You can put in whatever description you want. Now, the next choice that it gives you is this a public or is this a private repository? If it's public, anyone with this URL can go and look at your repository. Generally, you're going to want to do this if you're writing your code for the world to consume. So if you're writing modules or open source, GitHub is the perfect place to put it. Anyone that is looking for a solution for how to make a fast JavaScript loop, you might write a really fast JavaScript loop in this class, or a search algorithm. You're going to publish that and you're going to say, I've done this work and I want the rest of the world to have it. You would make it public. Generally in your careers, when you're working at a company, almost all of your repositories are going to be private because you don't want random people seeing your stuff. So public, visible to everybody. Private, visible just to the people you give permission to be visible. For the sake of this class, we're probably going to make most things public, with the exception of if you've got homework and stuff, that will probably be private to you, but shared with me. Got it? I shared with Selena as our friendly and excellent TA, right? We will probably do some small projects where you're sharing repositories amongst each other. You could make those private, but make sure that everyone that's on your team has access, but that other teams do not have access. Generally, we'll try to tell you which to pick, but as you get a little bit more comfortable with working in GitHub, you'll start to be like, oh, this is for the world, public. This is something I'm just doing as a portfolio, public. This is something that I'm doing personally. Maybe you start out with it private, okay? So we're going to make this first one public. Now, normally, if you were doing this first, if we didn't have a repository already on our computer, you would want to, you would probably say like add a README file, add a gitignore file, which we haven't even talked about yet. But a gitignore file is basically a configuration file that tells Git to ignore a bunch of files. Later on in this course, when we're learning how to write Node and JavaScript that write Node modules, Node is a system that creates a whole bunch of random files like configuration files and .env files and a bunch of nonsense that help Node run on your computer. But you don't want to commit it into your repository because if I run it on my computer, I might have different requirements, so my config files are going to be different. So gitignore is a special file that says, hey, ignore a file if it's named this. Ignore all files that say .env at the end. If we're on a Windows computer, it might be we're going to ignore everything that's .exe. And so GitHub has graciously provided us this list of like, these are templates of gitignore files based on the type of project you're doing that that you can probably safely exclude from checking into version control. Okay, so if we were doing a JavaScript project, JavaScript. Where's JavaScript? No, it's probably under Node. Yeah, so we would pick Node if we were doing a JavaScript thing, and it's going to have a whole bunch of stuff in it. But we don't need a gitignore because we already have a repository. And if we were doing this public, we were making something open source, they would want us to choose a license. So these are open source licenses that tell other people. So if you write some code, technically by copyright it belongs to you. But what you're doing when you put it up for open source, you're saying you're allowed to use this something I created under these conditions. So like the GNU General Public License, that license says you can use this all you want, but you have to also make sure that if you make changes to it, those changes remain open source. So no company can go and take your open source and then turn it into a business and make a bunch of changes and not share it back to the world. They have to share it. That's what the license says. The BSD license says, I wrote this as open source. I don't care what you do with it. You can go start a business like TCP/IP, the underlying infrastructure of the internet that we talked about briefly yesterday. The TCP drivers that most computers have is a derivative of TCP drivers that were built back in the 1960s and 70s. A lot of them, the BSD in here stands for Berkeley Software Design, because Berkeley, the university, was one of the first people involved in the ARPANET originally, and they were writing all this stuff, and they were like, we just want the world to have this technology we invented. Please use it. And so when Microsoft came along, they were like, this is a really good TCP/IP driver. We're going to use this for ourselves. And so BSD says you can use it any way you want, as long as you maintain in your source code, you say copyright of the original authors. So it's a really easy and friendly. There's a whole bunch of licenses in here that you can choose from. In general, you're good just picking GNU or BSD if you're writing open source. But that's going to be up to you, and you're gonna if you're working on a project that already exists, it might already have a license, and you just need to follow what that license says. Most of these licenses are like a page long, and you can read it and quickly be like, I can use this, and it tells you how you're allowed to use it. Okay, but we're gonna put none. But because, as I said, because we already have a repository, we're gonna leave all three of these things unchecked. Okay. All right. So this is ready. We're gonna click Create Repository. All right. Now you're gonna get to the repository page itself. It's created it. This is the URL to my repository up at the top. Your URL is probably going to say your name in here, and if you've got a different name for your repository, or if you picked a different folder name or whatever, this part is going to be different as well, right? This is how you address. This is like the address of your repository, your official formal address. it's kind of walking through the quick steps. So a lot of the stuff that we've been doing today to get to where we are and learning a little bit about Git, you're seeing that it's got all this stuff in here already as like do this and this and this and this, right? So this would be creating a README file, creating, doing git init for the first time, adding the README file, committing it, creating our branch. This is the important part. This is where we link our computer's version to GitHub, this line. And it's down here as well. So if we grab this line of code, because we have an existing repository we want to push, we pull up our thing. Now, you Mac folks, Andrew and Estrella, yours might be a little different because your branch is named master. Go ahead, Gregory.
How do you get that quick on GitHub when you said the quick settings, quick setup?
It should be on the page after you clicked the create repository button on the previous page.
Yeah.
Put in the title.
I didn't get that. Okay.
Share your screen. Let's walk through it together. If you miss these steps, it's going to put you a little bit behind forever because you're going to do this pretty often.
Share.
Okay, so you left those boxes checked when we. So you clicked the box that said create a README, and you picked a license. So it created the repository and put stuff in it. The reason we left those boxes unchecked is because we wanted to have it be blank. So what you can do, and this is going to be good for everybody, click those 3 dots over there and go to Settings. And then if you scroll all the way to the bottom, scroll all the way to the bottom. There is a delete this repository button. Click that. And GitHub is extra cautious. They're going to make you type in that full word, Ronin Samurai 2077 /git repo, to make sure that you know you're about to delete something forever permanently. Okay? And you probably have to, they expect you to, yep. So now you can click the button. Perfect. So that repository no longer exists. So do the same thing. Now you're, yep. We want to make sure that none of those boxes at the bottom are checked. Yep, perfect. So there you are. We're all at the exact same spot. So I'm going to share my screen again. All right. So we're here. We're at the quick add. If we were building a new repository, we could follow the steps up here, and we'd be almost identical to where we're at, but without as many cool files that we built today. Or because we have a file, we can copy this, right? So we can copy this line of code and come into our terminal and click paste. So it's going to say git remote add origin, and then the link to your repo. And then we hit enter. Is everybody following along? Yeah. All right. So now the git remote is telling it's the git command saying, hey, I care about something outside of myself. So anything after remote, right? There's a whole bunch of subcommands, and we can learn about that later. We might delete an origin. We might add a coworker's computer. But in general, this is the basic thing you're going to do pretty frequently, which is remote add. Origin is just the name, so you can name this whatever you wanted. But origin is a term you'll see in almost every tutorial. So if you're looking stuff up on GitHub, or if you're looking stuff up on how do I add a remote, almost all of them are going to use origin as the primary name or label for the main storage of your repository. But this could be anything. We could have remote add backup or offsite, right? Any name you put in there is how we're going to reference it with the rest of our commands. And then you put in the link to your repository. Okay. Now that that's added, we can look back at GitHub, and it says git branch -m main. Okay. I don't know what git branch -m means, so let's pull up our little handy cheat sheet, which is over here. That's not where it's at. Over here. Yep. So let's see what that does. Git cheat sheet. Git branch. Let's see if there's an answer in here. I don't see it. So we are going to search Google so we can learn what that means together. Git branch -m. And I saw somebody had a question. Who was that?
Oh man, I wonder where you get the GitHub cheat sheet from.
I searched it on Google, and it was one of the top results. I'm going to share that with you
Oh,
guys tonight. Almost everything, the answer to almost every question is I just looked on Google for Git cheat sheet.
Basically, Google is your best friend.
Google is 100% your best friend. It will be your best friend until you no longer are working as a software developer. So, git branch -m. Let's see. Git branch. Yeah. We can also maybe look in our help. Right? So git branch help, maybe? Let's try that. Oh, it opened a website for us. That's interesting. I've never seen that before. Git branch -m. Let's look at. Okay, so this is especially important to you folks on Mac. So what I believe is going to happen is right now we're in main, and if you run git branch -m main, it's going to rename your current branch to main. So why don't you try running that right now? I think all of us Windows folks probably don't have to do this step. But I'm going to test it and see what happens. Yeah, did nothing. But let's try git branch -m. Weird. Okay, yeah. So that renames your branch. We learned something together today. Git branch -m main. Okay? So now, everyone that's been on a Mac, type in the word master. If you run this command, git branch -m with a capital M, and then put main, now your primary branch is main. Which is important for the next step because GitHub by default, and I mentioned this yesterday, they changed from master to main as the default, and that has kind of been a ripple effect through the entire software engineering industry. A lot of companies have been working for like 10 years using master as their primary branch, and now we're changing to the word main, and so you're seeing this transition happening slowly. So you might go somewhere and it'll be master, you're going to go somewhere else and it's going to be main, you might go somewhere else and they've got a random, like, some silly name. Who knows? Okay? Then, to get all of our stuff that we've been working on all afternoon into GitHub, we're going to run this command, git push -u origin main. And I'll describe each step of what that's doing here in a second. Git push -u origin main. Okay? What this means before I hit enter, push, if you remember from our early discussion, push is sending, pull is pulling, bringing data down. We're going to be sending all of our content, which includes -u, is like all the history, all the tags, everything that we've done to date, up to GitHub. And we're doing it to the origin, right? So that tells us we just added the repo origin. We're saying send everything to origin from our repository main. Okay? So if I hit enter here, you're going to see a bunch of crazy stuff happen because it's going to, it's making me connect with, if you guys are on Windows, this is probably going to pop up for you. Everyone on Mac, as soon as you hit it, it probably started sending stuff, huh? Andrew and Estrella, did it?
So it popped up when I hit enter. It popped up. Says username for https github.com.
Okay.
So.
So that's So let's try something else. Yep, and it did the same to me. So we'll type that in, username, and then it's going to pop up a box that says password. So let's type in our password. Where did I make my password? Hopefully that was. I failed. If you remember using a password, you should be able to do it that way. We can try. This popped up. I've never seen this box before, so this is new to me. I don't know what that means. I'm getting a weird error. But it brought in this authorized Git credential manager. I'm going to click yes on this. Authentication succeeded. And I can return back to here. Great. And it worked. So all the Windows people, you can click that authenticate with GitHub thing. And all the Mac people, you're probably going to have to type in your username and password.
Didn't we click through and not put a password earlier?
No, this is your password for GitHub. So this is using authentication into GitHub. And the reason we had to do this is because we put our origin, if you remember from our origin command, we said use HTTPS. In general, the SSH stuff we did would be if we were linking to an SSH version of GitHub, which I'll show you that in a minute. That's the preferred way to do it. When you go get a job, you're probably going to use SSH, which is why those keys need to exist. But we picked HTTPS because GitHub gave that to us for whatever reason. Okay?
Mine's not working.
Key, but it's not letting me type yet.
Why don't one of you share your screen and we'll look at it together?
Who wants to go first?
You can, I'm good.
Okay,
Okay,
Selena, you go first.
Okay.
Or go ahead.
Sorry. Yep.
Okay. Git push dash u origin main. Pull up your GitHub page. Yeah. Can't remote add origin. That's weird. All right, Selena, you try this. You see that little button there that says SSH on your GitHub page? Copy that.
This right here?
Yep. Click the SSH button first.
Oh, click it. Okay.
Okay. Copy that string. Okay. And then we're going to do... Give me a second while I look this up. Let's see. All right. So we're going to type in your console git remote space rm for remove and then space origin. So we're going to delete your origin because I don't know what's going wrong with yours. Okay, but we're going to do it the SSH way. Now we're going to do git remote add origin. And then you're going to paste that string we just copied from GitHub. So shift insert. Yeah. Hit enter. Okay, now do git push dash u origin main.
Enter.
Yep. Failed to push some refs. Okay, let's do git push origin main without dash u.
Like that, yeah?
Yep. Okay, let's do git status. Let's see if there's a hang up here. Okay. Because you are in the wrong file. That's why. We were in git repo, and you've got a whole bunch of stuff that was added. So.
Yeah, you know what? Up here. Nope. Here. I was like, I don't.
Yep.
It wasn't letting me go somewhere.
Yeah. So what happened is you've created a Git repository in your week 1 homework 1 folder, and it's full of a bunch of crazy stuff. Okay. Mm-hmm. So what we're going to do is this. Scroll back down to the bottom, and this is good advice for everybody. All this crazy stuff, you've created a repository outside of a repository, and it's all incorrect. The way to delete this is to rm-rf space -rf. Actually, instead of rf, let's do ri. F is a force, and so it's going to delete without asking us questions. We don't want to try that. And then space .git. So there's a Git repository that exists inside this folder that is not right. Okay.
Enter.
Yep.
Okay.
Okay. So this tells us that the Git repository does not exist in this folder. So let's go up into CBC 12. That's probably where it's at. cd ... Okay. Let's do ls-a to see if it's in here. No, still not there. Let's cd ... ls-a. And then space. Yeah, that's fine. Just press up if you got an up arrow. And then space dot git. And I would be willing to bet there's one here. Yeah, okay. So there's a Git repository in your main home directory, which is probably not what we want at all. And the problem is, if you got a Git repository that's initiated in a folder that's above a folder down below, it's going to operate on the one way above. So what we're going to do is delete this one. So rm-ri .git.
Like that?
Yep. Yes, Y, enter, Y, enter, Y, enter. Yeah, so we want to delete this whole thing. So just Y, enter a bunch of times until you get back to the main thing. Perfect.
Okay.
All right, you're all caught up. So now let's go back into CBC 12. Okay. CD CBC 12.
Oh.
CD into week 1, homework 1.
Homework 1?
Yep.
Okay.
Whatever you, maybe it's not homework 1, whatever your folder is called. Week 1 homework. Enter. Yep. And then CD into your Git repo.
Just Git repo?
Yeah, whatever you have it called. And you can usually, like, as soon as you start typing a letter, bang on your tab key because it's going to fill out the word for you. Yeah, perfect. Enter. All right, perfect. So there is a repository in here. Everything should work. So let's try git push -u origin main.
Git push -origin main?
Let's actually, before we do this, let's run a git status first and just check and see where we're at, because having a repository above might have messed things up. Okay, so everything's good. So yeah, git push -u origin main. Okay, perfect. So we don't have an origin set because when you ran git remote add origin, it was putting it in the top repository. So we have to run that first command, git remote add origin. And you can just copy that line directly from behind you on the Git website.
Here?
Yep, that top line. Perfect. Yep. And go back into there. You put a dash in front of origin. That needs to not be there. Yeah, you're going to probably have to move with your keyboard. Yeah. All right, and then hit enter. Git remote add origin. You forgot add in between remote and origin.
That's okay. We're learning, right?
We sure are. This sort of stuff happens all the time, and it'll drive you crazy. Perfect. You forgot to paste.
Oh my gosh. Okay, hold on. We'll get there. I'll get there.
Yeah. Perfect. Enter. Make it so. All right, now press up, 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 I think. Up a couple times. Up more. Yeah, perfect. Hit enter. And then click yes. Y-E-S. Enter. So what this is saying is, this is the first time we're connecting to GitHub, and this is only going to happen to Selena because she used SSH instead of HTTPS. It's saying, do I want to remember that that when I connect to GitHub, this is the information. And so now, if you reload your GitHub, and this should apply to everybody. So let's go, let me share my screen again. We should all be at the same type of step right now. So I'm here. This was the page we were on. We were following the instructions. But if I reload now, I see all of the files we've been working on all day. Right?
I'm not at that point.
Okay. Where are you at, Andrew?
Let me. So I'm still at the point where I put my username in for GitHub, and then it's asking for the password, but it's not letting me type the password.
Okay, it's letting you type the password, but as a security feature, it's not
invisible.
displaying that you're typing anything.
Okay.
So you're going to have to just hit backspace about 20 times just to make sure that it's clear, and then type in your password and hope you did it correctly.
Okay, it says fatal authentication failed for
Okay.
GitHub.
So you probably also incorrectly typed a password or something. So we're going to do the same thing that we did with Selena. So you are going to type this. Let me pull up my thing. So we're going to type this in your console. Remote RM origin. Okay. Hit enter. Okay. Once that's done, you're going to click on the button that is in your GitHub page that says SSH instead of HTTPS. Should be like right around here. Do you see that button?
Here, let me share my screen. It might be a little
Perfect.
easier. The problem with my password is I've got the strong password touch thing on my Mac. So it just creates strong passwords. So I had to go and look that password up.
Yeah, that's annoying. SSH is a more secure way of authenticating than HTTPS. So the default way that they have us doing stuff is dumb and incorrect, but they're making us do it for I don't know why. But we're going to learn to do it the right way. So bring up your GitHub.
Right.
You see that SSH button that's right there next to HTTPS? Oh, cool. Go back.
Oops. Go back to the
Git repo. Yeah.
Gotcha.
It says SSH right next to HTTPS. And you'll notice it changed the address of your repository in the box right to the right, but it also changed git remote add origin. So that's different now too. So let's copy that entire line, put it into your terminal, hit enter, and then press up 3 times. Yeah, right there. Hit enter. And now this is going to work like magic. Going to type yes, yes. And you're only going to have to ever do this once because it's saving it in your cache. Hit enter. And now, if you reload your page, you'll see what everyone else sees, which is all the stuff we've done today. Cool. Gregory, did you have a question?
Yeah, I realized I did the same thing. I know how to do it. I added change it, but I just need to figure out how to delete the HTTP.
HTTPS one. It's git remote RM origin, just like that, and hit enter. And then you can click the SSH button, and then you'll be able to do it that way. Are we all at the same spot? And if you ever need to know that address again, if you go to code, it's right in here as well. Right, you can see the HTTPS version, which is just the web address, and you can even paste that up in here, right?
Say get remote origin.
For which part?
To remove
get
HTTP.
remote RM origin, just like this.
Okay. I thought I had to type in RM in the address. All right.
Yep. Git, and this is just running the RM command, which we used for removing files, right? It's got the same kind of language here. So git remote remove origin.
Type it and just start over again.
And then when you're back on GitHub, you're going to click the SSH button and paste that top line. So it's going to say git remote add origin. Add origin. And it'll be something like git at github.com / your username / git repo, right? Whatever you named your thing. So that's what it's going to look like now instead of HTTPS. Do you see that line?
Click yes to fingerprint.
Just type yes. Yep. And then hit enter.
Type yes.
And then
please make sure you have the correct right access, and the type. I don't know what's going on.
Okay. Well, we can stay after class. I want to just keep going so we can finish up today,
Alright.
and I'll try to help you out individually. Um, this is like super important, and you're going to do it a million times. So, even the homework that we're going to release for tomorrow is going to kind of cover the same steps. It's going to ask you to create a brand new repository, create some files, upload some stuff. So you're going to do this again tomorrow, and then you're going to do it again when we start working on homework assignments. A lot of the homework assignments when we get into the programming stuff is going to be like make a repo, upload an HTML file, send me a link, right? A lot of stuff like that. So you're going to do this over and over and over again from now until the end of time. Okay, so we've got our repository here. We still have a repository locally, okay? So I can now work on this on my computer, make a bunch of changes, and now there's a repository off on the internet that the whole team can see that doesn't know my changes. So let's just quickly go through this as a quick example. I'm going to kind of breeze through this because we're kind of running on low on time today. We'll probably touch on this again tomorrow, and this will get reinforced time and time again. But I wanted to quickly show off some of the code collaboration features in GitHub before we move on. Okay? But please, please, please stop me if I'm going too fast. Everybody following along? Okay. So I'm going to make a new branch, get branch, or let's do get checkout -b, and I'm going to call this fun feature, right? So I'm making a brand new feature. I'm in a new repository. Inside my repository, I have my unicorn images. I got my to-do, but I'm going to make a thing that says readme.md. Okay, and this file I'm going to say, I used vi instead of nano readme.md. I'm going to say this is our cool project, right? Look at how awesome we are at GitHub, right? I'm going to write this file. I'm going to make another file called magic.js. I'm going to put some stuff in here. Hello world, right? Great. Exit. Yes. Okay. Now if I do git status, it's going to show me I got 2 new files in this thing. I'm going to say git add dot, so we're going to add it. Then we're going to commit -m, first commit of new feature, right? So now we just made a commit. We've been doing this all day long. It's a brand new branch that exists, but GitHub doesn't know this branch exists. Now, normally how you're going to work in a collaborative environment in an office where you guys are using a tool like GitHub is that you're going to work on your computer and you're going to push branches up to GitHub. So this is how we're going to do this. So what we did to push our main branch up was we said git push -u origin main. But main is the main repository. We want to push up fun feature. Right? You guys following along? Okay. So when we type git push -u origin fun feature, it's going to push this brand new branch we made up into GitHub. And you should be able to see branch fun feature set up to track remote branch fun feature from origin. That's just telling you now GitHub knows this branch exists. Everybody's happy. If we reload this page, you'll notice right now GitHub only knows about that one main branch, main. If I reload this, it's going to tell you right off the bat, because something just recently happened, it assumes you're probably going to want to do something with it. But if we'd waited 10, 15 minutes, this box wouldn't have popped up. But you can see we've got 2 branches here now. If I click on this, you can see that we've got a main branch, and then GitHub is also going to show you the branches that I own, that I created in the first place, and it's going to show other branches that are active. Okay, so we can go in here and we can see this branch has a README file and it has a magic file. Those are our 2 new ones. So all the stuff we were doing in the command line up till now, ls, changing directory, looking around, changing branches, we now can just do through the web page just by clicking on this. Right? Main still just has no README file and it has no magic.js, but our new fun feature branch has those. Right? Is everybody following along so far? It's the same thing, but on a pretty website instead of in a terminal. Yes? We're good? All right. Now, how you'd normally work is you say, I am done with this file. Remember, before we were doing all this manual merging, traditionally when you're working as a software developer, and we're going to do this a bunch of times, so don't at all think you have to memorize everything perfectly tonight, we are going to, in our branch, you can either do it from here, we can click New Pull Request, or we can do it from this button, new pull request. But we're going to do it from here because this is where it'll be most of the time. That other little box that pops up only happens for like the first couple of minutes after you first push a brand new branch. So we're going to say fun feature is ready to go into main. Like this is ready to launch. But most companies are going to want to put a couple other people reviewing your code before they'll accept things into the main branch. Remember we were talking about QA teams, putting it on test servers, running it through a bunch of test procedures. But your process is going to start with your pull request. So this is opening a pull request. It's saying, hey, I want to move this fun feature branch into main. I'm going to give it a title. Some companies will ask you, a lot of companies will say, you need to explain how to test it. So they say like, open up the branch and verify that the README file exists. Right? You might put a whole bunch of instructions in here how to do the work. You can put in a reviewer. So if you're working on a team, you can request people to say, hey, before this gets launched, I want you to approve this. We do this all the time at my day job. You're going to do this all the time at your companies in the future. You're going to pick reviewers. There's a lot of different ways to pick reviewers. Some companies say like, if you're working on back-end features, your senior back-end developer is the reviewer. If it's a front-end feature, it's the designer. You can assign it to someone or you can assign it to yourself. The assignee is generally like who's responsible for making it. So at some big companies, you're going to have one person who's responsible for all the pull requests. But let's just assign ourselves, right? So I am the assignee. This belongs to me. Some companies might have you put labels and things. So it could be like, this is a bug, this is documentation, this is a feature. All of these labels are configurable in GitHub. So you might get on the job site and they've got a whole bunch of crazy labels. Who knows? But we can just say we added some documentation. If you're running projects, this would be where you'd say this is for this project. We don't have any yet. And then milestone is if this is for a specific, like we're launching 1.0, like this is for 1.0. There's a whole bunch of tools behind the scenes in GitHub that makes it easy for large teams to manage the flow of work. We're probably not going to do many of those here because the idea is we're trying to train you to be an entry-level junior software engineer. You're going to be able to go in and write code. So you'll probably do pull requests like this all the time, but you're not managing all the pull requests to make sure that your whole company is aligned, right? But once we've got a few of these things set up, you can see this is what I was talking about earlier. Like there's it's showing the changes that we made to files. If we had, the stuff we were doing with git diff, or when we were looking at some of that stuff earlier this afternoon, this is just a cleaner version of that. It's the same information. You still see the plus signs. It's still showing you, hey, we added a couple lines here. If this was multiple commits, you'd see that in here as well. Right, then we click create pull request. Now, when you're an individual developer working on a project just by yourself, it's a good idea to still use pull requests so that you have a log or a history of all the things that have changed. Like this is documentation of your development process. So even if I'm doing this by myself, I'm still probably going to do pull requests like this just so I know all the things that have changed over time. But in here, this is the GitHub reviewing process. So if you had marked a bunch of reviewers in here, and we will probably mark reviewers in this class, you'll probably pick me for things. I'm going to go in and review your pull requests and make suggestions or corrections or ideas for improvement. But that would happen in this pull request process. So if I'm a reviewer, I'm going to click on the commits. I'm going to come in here and I'm going to click on things. GitHub lets me do a whole bunch of things as a reviewer. Like I can look at this and be like, you have an extra blank line in here, right? And I can either add a single comment or start a full review. Generally, when you're doing a review, you've submitted a pull request for a pretty big feature. There's usually a couple hundred lines of code in here. So I would almost always start a review and just go through looking for deficiencies or problems. Maybe it's style guide issues. But once I'm done with my review, I'm going to finish it. And I'm going to either say, hey, this is good to launch, or this is I'm going to leave a comment, or I'm going to request changes. Okay? So now if I was not the reviewer, I'm the person that just submitted, I can come in and see it and be like, oh, I have an extra blank space in here. So going back to our engineering workflow, right? If I fix this feature, because this guy said, hey, there's an extra blank space in here. If I come in here and I take out this blank space, right? Save, yes. So now I've made a change, so I can do git add dot, git commit -m removed extra space from pull request review, right? and then git push origin fun feature. Right? So now I've made the change that was requested, and I've uploaded it back into GitHub through the push feature. And if I reload this page, it's going to show me that this is outdated now because you have submitted a new pull request that changed that line of code. Right? So you can see how this is a really powerful tool, especially for distributed teams, to let you quickly and easily collaborate on software. Okay? So me as the reviewer, I would normally go in and be like, yep, you fixed it. I'm going to resolve it. I can still see that it's there, or I can view the changes. I can see, like, this conversation was marked as resolved. But now you can see that the commit had 2 commits, and one was to remove that extra space. You can see now that it shows that diff. Okay. Any questions of this pull request process? We're running super short of time. I promise you we'll touch this again tomorrow morning. You're going to touch it with your homework tomorrow during lab time. This is fundamental and foundational. Is there any questions with what we've seen so far, or any questions in general? The final step of this kind of pull request process is if I click this merge pull request button, it's going to merge that into main. And all the stuff we were doing with git merge on our computers is, so you're all set. So now you have the option in GitHub, if we're done with this feature, this branch completely, I can click this delete branch button and it'll be the exact same as if I had typed git branch -d on my computer. So if I click this, yep, we're done. Great. But now we can see that I can go back to the regular code, and we'll see the cool thing is all the files that were changed in this last, like this list view when you're in code, shows you the most recent commit that touched that file. So we can see removed extra space from pull request review was the last thing for README, right? Because that was the last commit that touched that file. Any questions? The last little part of that is, if I'm a developer, I just submitted this, the pull request was completed, I would go back to git checkout main, and then I'm going to make sure my main is out of date with what's on GitHub now. So I would do git pull. And so now I get those files, git readme, and the magic file as well. Okay? Any questions? We got like 10 minutes left. Happy to answer anything. We will talk about this again more tomorrow. You're going to play with it a bunch in lab tomorrow. But this is really important.
I've got nothing right now.
All right. Estrella, Andrew, Leah, Gregory, you all good? All right. It has been a long, long afternoon. We have covered all there is to cover in Git, and there's about 7,000 more things that you will eventually touch in your long career. But there's stuff you're not going to touch every day. So when those things come up, you'll just go and Google, like, how do I do that? Like, you'll probably at some point check in a file into the wrong repository. So how do you back out that change? That's something you'll do occasionally. I never remember the command, so I always go look it up on Google and just type in what it tells you. Gregory, you're gonna stick around for a few, and then we're gonna try and get you caught up with the GitHub stuff. But if nobody else has any questions, we'll see everybody tomorrow, bright and early at 5. Lab starts at 1. I'm gonna release your homework for tomorrow, and I'm also gonna upload that cheat sheet so you guys can reference it. It's a pretty good one. But if there's nothing else, we'll see everybody tomorrow. It's been another good day. How are you guys feeling so far? Pretty good?
It's pretty good, pretty good. It's just that I need to basically remember all the commands. Well, mostly of all commands, or have it down someone to know what the meanings are.
Yep.
And etc.
Everybody
But pretty
learns differently, so I need to like type it in myself or write it down for me to remember something more than once. Some people like to listen, some people just like to look. Whatever learning style works best for you, I'd encourage you to do it. And
I just need a reference page.
Yep, and then we will do these things over and over and over again for the next 10 and a half weeks. So I promise you will be good at this. All right.
All right.
If there's nothing else, I'll see everybody tomorrow. Gregory, stick around. We'll share your screen. We'll get you figured out. Thanks, everybody.